Hey guys, good evening and welcome back again to your Unacademy NEET English channel. I hope all of you are doing great, having a good time. So my dear students, quickly just let me know in the chats if all of you can hear me, if I'm perfectly audible and visible to every one of you. Quickly let me know in the chats with the thumbs up. Everyone, people in the chats, all of you can hear me? Am I perfectly audible, visible to everyone? Good evening, guys. Good evening. Good evening. So finally, we are going to start the new journey of your NEET 2024 as well as 2025 through the NEET Conquer batch, which we are starting today, basically. Today is the first session of the NEET Conquer batch, right? And my dear students, as I have promised you already, in this NEET Conquer batch, we shall be doing exactly one chapter in one day with the help of detailed marathon, which covers all the basics, all the problem patterns which can be asked from a particular chapter, right? Session duration can be between 5 to 8 hours, right? So first of all, I would just want to ask you a question. Are you ready to be with me till the end of the chapter, till we complete the chapter tonight? Yes? Quickly, let me know in the chats. Quickly, let me know in the chats, everyone. Everyone in the chats, quickly. Are you ready for it? Are you ready to be with me till the end? Yeah? Wonderful, guys. Perfect. So first of all, I would want you guys to make a separate notebook from today onwards. Okay? Whatever things I'll be mentioning on the screen, I would want you guys to take a note of every single thing. Because whatever I'll be teaching here, whatever every teacher will be teaching here in this NEET Conquer batch, which is absolutely free for all on YouTube, all the points are going to be really, really very important. Right? So as you all must be knowing, tonight we are starting with the first chapter of your class 11th chemistry, that is the mole concept. One of the most important chapters as far as your physical chemistry is concerned. My dear students, again, as I kept on telling you all the time, if your mole concept is strong, if your first chapter of class 11th chemistry is strong, that means your entire physical chemistry is going to be strong. If there will be issues in the mole concept, if there will be doubts in the mole concept, that means in your entire physical chemistry is going to be full of doubt. So make sure you study this particular chapter from the basics, cover all the problem patterns with me in the tonight's session. Right? Perfect. Someone is asking, is it only the mole concept? It is not only the mole concept. It is the complete first chapter of your class 11 chemistry. The actual name of the chapter is Some Basic Concepts of, which I will be starting exactly from the basics, from the scratch, right? As if you have never studied this chapter before. Is that cool? Are you guys ready for it? Are you all ready for it? Quickly in the chats. Quickly, my dear students. Let me know quickly in the chats. Yes, I'll be giving you the session PDF as well at the end of the session. All right, in the Telegram group. Okay, session PDFs and written session PDFs will be provided to you at the end of the session. So quickly, let me know in the chats if all of you are ready for this amazing session, amazing batch, which we are going to start today. That is the NEET Conquer batch, my dear students. Yeah? Okay, let me give you the schedule of this particular week, first of all. So today it's Thursday. And Thursday at 5 p.m. it is the mole concept chapter which we are doing. Tomorrow on Friday at the same time, 5 p.m., Shreya sir is doing complete vectors, right? Saturday, it's going to be Ambika ma'am who will be taking care of your complete chapter, the living world. And my dear students, on Sunday or Monday, I exactly don't remember. I think it's on Sunday, yeah. On Sunday, it's going to be HSP sir who will be taking care of your general organic chemistry in one shot. All the sessions will happen on this particular channel only, right? So basically in a week, we'll be targeting 4 chapters. That means 40 marks approximately. Yeah. So this is basically the schedule of the week, which we shall be following on this channel in this particular. Okay. All the sessions will start exactly at 5 p.m. every day. Okay. Oh, people are saying Monday is GOC, all right? So Monday is GOC. So that means one day you're getting in between, that's Sunday, right? Wherein you can revise all the 3 chapters, which will be done till then. Perfect. Guys, so quickly, let me know in the chats. Everyone liked the session yet? Well, I can see only there are some 604 likes. You need to increase it to 1,000, guys, quickly, right now. And if you have not subscribed to the channel yet, I would want every one of you to subscribe to the channel as well. And if you have not shared this particular video with anyone, do share it with everyone. Let everyone whosoever cannot afford the paid batches, right? Let everyone join the sessions and get benefited out of these free sessions, which we are going to take here on this particular. So ready for the session? Are you all ready for the session? Are you all ready for the session quickly? Wonderful, guys. So I'm starting the chapter exactly from the basics, from the scratch. And slowly, we'll be covering all the things which are there in the chapter. Okay? My dear students, the first point, the first topic from which we start the chapter, that is atomic mass. If you ask me what atomic mass is all about, my dear students, let me tell you, atomic mass, it is defined as the mass of single atom of an. Atomic mass is defined as the mass of single atom of an element. For example, if I'm using the term atomic mass of oxygen, that means I am talking about the mass of one atom of oxygen. If I'm using the term atomic mass of fluorine, that means I'm talking about the mass of one atom of. If I'm using the term atomic mass of sodium, that means I am talking about the mass of one atom of. So in short, what atomic mass exactly is? Atomic mass, it is defined as the mass of single atom of an atom. Number one, the basic, it's classical definition. In order to make you understand the actual definition of atomic mass, I will have to tell you some basic things. And what are those basic things? Let's have a look. My dear students, as I keep on making you understand with this particular example, have a look. Let's say I have taken an object over here. This is one object. And I'm assuming weight of this particular object, it's 5 kilograms. Similarly, I'm taking one more bigger sized object. Let's assume the weight of this particular object, it is 10 kilograms. I took two objects. Weight of the first object is 5 kilograms. Weight of second object is 10 kilograms. Now, my dear students, can I write this 5 kg in this format? 5 multiplied by 1 kg? Absolutely, I can do that. Can I write this 10 kg like this? 10 multiplied by 1 kg? Absolutely, we can do that. Now, the point is, why am I doing this? Why I wrote this 5 kg as 5 multiplied by 1? Why I wrote this 10 kg as 10 multiplied by 1 kg? There's a reason behind it. Dear students, can I say this particular object, it is 5 times heavier than 1 kilogram? Absolutely. Can I say this particular object, it is 10 times heavier than 1 kilogram? Absolutely. My weight is 75 kilograms. What does that mean? That means I am 75 times heavier than 1 kilo. So in short, what am I doing exactly? Can I say, actually, I am comparing the masses of different objects with this 1 kilogram. I'm comparing masses of different objects with this 1 kilogram. I'm exactly checking that this object is 5 times heavier than 1 kilogram. This object is 10 times heavier than 1 kilogram. I am 75 times heavier than 1 kilogram. So basically, I am comparing the masses of different objects with 1 kilogram, right? So what this 1 kilogram here is, can I say this 1 kilogram is basically the reference here? It is the standard here with which I am comparing the masses of different objects. Absolutely. This 1 kg is the reference here. It is a standard here with which I am comparing the masses of different objects. My dear students, like we have got 1 kg as the standard here, I would need a similar type of standard in chemistry. I would need a similar type of standard, a similar type of reference in chemistry with which I will be comparing the masses of different atoms or molecules. Right? Now the point is, what is that standard in chemistry with which we are going to compare the masses of different atoms or molecules? Let's have a look exactly what that standard is. My dear students, in order to make that standard, what I'll be doing exactly? I will be taking a carbon 12 atom. I will be taking one carbon 12. Let's assume this is the carbon 12 atom over here which I have taken, right? Now people, I'll be simply dividing this carbon 12 atom into 12 equal parts. I divided the carbon 12 atom into 12 equal parts. Now if I take one part over here, this shaded part, can I say this shaded part, its mass is going to be 1/12 of, its mass is going to be 1/12 of the mass of the whole carbon 12 atom? Right? Can I say something like this? Absolutely. I took one carbon 12 atom. I divided the carbon 12 atom into 12 equal parts. Now, I'm taking one small shaded part over here and I'm saying the mass of this shaded part, the mass of this small part, it's 1/12 of the mass of. Now, dear students, this 1/12 of mass of carbon 12 atom, this 1/12 of mass of carbon 12, the mass of this particular shaded part over here, that's something which you call as 1 AMU. You can call it as 1U or you can call it as 1D as well. Let me tell you, this AMU over here, it stands for the atomic mass unit. It stands for the atomic mass unit. This U over here, it stands for the unified mass. It stands for the unified mass. And this D over here, it stands for Dalton. So what exactly I did? I took a carbon 12. I divided the carbon 12 atom into 12 equal parts. Then I took one small part. And I'm telling you, mass of this small part, mass of this shaded part, it is basically 1/12 of the mass of carbon 12. And 1/12 of the mass of carbon 12 atom, that's something which I call as 1 AMU, or you can call it as 1U, or you can call it as 1D, right? I hope everything is clear till here. Now, my dear students, what scientists exactly did? What scientists did? They calculated the mass of one whole carbon 12 atom. They calculated the mass of one whole carbon 12 atom by using a technique called as mass spectrometry. By using a technique called as mass spectrometry, what scientists did? They calculated the mass of whole carbon 12 atom, and the mass of whole carbon 12 atom, it came out to be 1.99 into 10 raised power minus 23 grams. So this 1.99 into 10 raised power minus 23 grams, if I ask you, is this the mass of whole carbon 12 atom? Absolutely, this 1.99 into 10 raised power minus 23 grams, this is the mass of whole carbon. Yes, students, if you know the mass of whole carbon 12 in grams, can you let me know what will be the mass of this shaded part in grams? Absolutely. I'll be dividing this particular term by 12. I'll be getting the mass of the shaded part, right? As simple as that. Let me summarize everything over here in detail. My dear students, I'm writing a statement which is what you are going to remember from now on. I'm writing 1 AMU, which is basically 1U, which is what you call as 1D. How do you define it? 1/12 of 1/12 of the mass of carbon 12. 1/12 of the mass of carbon 12 atom. And the mass of whole carbon 12 atom, it came out to be how much? 1.99 into 10 raised power minus 23 grams. Now, if I'm dividing this number by 12, I'll be getting the value exactly as 1.66 into 10 raised to the power minus 24. Right? And dear students, this 1.66 into 10 raised power minus 24 grams, you can represent it like this as well. 1 divided by Avogadro's number, and its units will be taken in grams. 1 divided by Avogadro's number. Dear students, if you divide the number 1 by the Avogadro's number, whose value is 6.022 into 10 raised power 23, you'll be getting the value exactly as 1.66 into 10 raised power minus 24. So this is the first statement which I would want every one of you to remember from now on. This is important. Do remember this particular statement from now on. Okay, perfect. So what is 1 AMU? 1 AMU, you call it as 1U, you call it as 1D, right? You call it as 1D. Okay, it is defined as the 1/12 of the mass of carbon-12 atom. Since already you know the mass of one carbon-12 atom, you just need to divide it by the number 12. You'll be getting the value of 1 AMU. You'll be getting the mass of 1/12 of the carbon-12 atom, which comes out to be 1.66 into 10 raised power minus 24 grams. My dear students, you can write it as 1 divided by Avogadro's number. Is this part clear to everyone till here? Quickly, let me know in the chats. This Na here is the Avogadro's number. 6.022 into 10 raised power 23. If you divide 1 by Avogadro's number, you'll be getting the value exactly as 1.66 into 10 raised power minus 24. So quickly, my dear students, in the chats with the thumbs ups, if you got it properly, what I said till now. Quickly, everyone. Perfect. All right. Now, dear students, if it is clear to everyone, let's try to understand few statements. Here I'm writing the first statement. I'm writing atomic mass of nitrogen. Atomic mass of nitrogen. What does it mean? Atomic mass of nitrogen means that I'm talking about the mass of one atom of nitrogen. It means that I'm talking about the mass of one atom of nitrogen. And every one of you must be knowing that the atomic mass of nitrogen is nothing. It is just 14 AMU. Right? It's 14 AMU. All of you must be knowing. Now, dear students, this 14 AMU, can't we write it like this? 14 multiplied by 1 AMU? Absolutely, we can write it like this. No issues, right? Can I write 14 multiplied by? Instead of 1 AMU, can we write 1/12 of the mass of carbon-12 atom? Absolutely, we can do that, right? My dear students, instead of 1 AMU, can't we write 1.66 into 10 raised power minus 24 grams? Absolutely, we can do that. Instead of 1 AMU, my dear students, can't I write 1 divided by Avogadro's number in grams? Right? All these things we can write. The choice is all yours. The point is, what is meant by all these statements which I have mentioned here? Let's have a look exactly what is meant by all these statements which I have mentioned over here. I wrote a term atomic mass of nitrogen. That means I'm talking about the mass of one atom of nitrogen, which comes out to be 14 AMU. What does that mean? That means one atom of nitrogen is 14 times heavier than 1 AMU. That means one atom of nitrogen is 14 times heavier than 1/12 of the mass of carbon-12. Right? Can I say this is basically the mass of one nitrogen atom in grams? Or you can say this term over here. This is again the mass of one nitrogen atom. Quickly, let me know if all these terminologies are clear to you. Quickly, my dear students, everyone in the chats, is this particular statement clear to every one of you? Quickly, my dear students, quickly, everyone. Quickly. Yeah? Let me write one more statement in the similar format so that it becomes properly clear to you. Okay, let me use a different slide, just a second. All right. I'm writing a term over here. For example, I'm writing atomic mass of oxygen. Atomic mass of oxygen. What does it mean? Does it mean that I'm talking about the mass of one atom of oxygen? Yes, I'm talking about the mass of one atom of oxygen. Now you tell me how much it is. Can I say it is nothing, it is just 16 AMU? Can I say 16 AMU can be written as 16 multiplied by 1 AMU? Absolutely. Instead of 1 AMU, we can write anything. 1/12 of the mass of carbon-12 atom. Instead of 1 AMU, we can write 1.66 into 10 raised power minus 24 grams. Instead of 1 AMU, we can write 1 divided by Avogadro's number in grams as well. Now the point is, what is meant by all these terms? What is the meaning of all these terms? What is the meaning of all these terms? Right now, people, we are talking about the atomic mass of oxygen. That means we are calculating the mass of one atom of oxygen, which is coming out to be 16 AMU. That means one atom of oxygen is 16 times heavier than 1 AMU. One atom of oxygen is 16 times heavier than 1/12 of the mass of carbon-12 atom. This is the mass of one atom of oxygen in grams. Even this is the mass of one atom of oxygen. So what is atomic? What is atomic mass? If you want to define the atomic mass now, can I say atomic mass is nothing? Atomic mass is just a number. 14 in case of nitrogen, 16 in case of oxygen. Atomic mass is just a number which tells us how many times an atom of an element is heavier than 1/12 of the mass of. Right? Yes? What is atomic mass? I'm writing its definition now. Atomic mass is a number. Atomic mass is a number which tells how many times an atom of an element is heavier than 1 AMU. So dear students, if it is clear to everyone, let me know quickly in the chats with the thumbs ups. Everyone quickly in the chats. Someone is saying video is not clear. You just need to increase the quality of your video. Go and change it. I think you're watching it at 360, 140p. Quickly, people, if this particular definition is clear to everyone, do let me know in the chats with the thumbs ups. Yeah? Perfect? All right. So if the term atomic mass is clear to you, let's have a look on one more thing. My dear students, I took nitrogen in the beginning, right? And we know I took nitrogen in the beginning. Now, related to nitrogen, I'm going to write few terminology. First, I'm writing 14 AMU. Second, I'm only writing 14. And third, I'm writing 14 multiplied by 1 AMU. And instead of 1 AMU, I'm writing 1.66 into 10 raised power minus 24 grams. If you ask me whether all these terminologies are same or different, let me tell you, this 14 AMU is what you will be calling as the atomic mass of nitrogen. You should be calling this as the atomic mass of nitrogen. This 14 over here, you will be calling it as the relative atomic mass of nitrogen. And this particular term over here, you'll be calling this as the actual mass of nitrogen. Yeah? Okay. Similarly, if I take oxygen into consideration, yeah, I'm taking oxygen here. Dear students, related to oxygen, I'm writing again three terminology. Right? First, I'm writing 16 AMU. Then I'm writing only 16. Then I'm writing 16 multiplied by 1.66 into 10 raised power minus 24 grams. You need to let me know whether these three terminologies are same or different. These are absolutely different. The 16 AMU, you will be calling this as the atomic mass of oxygen. The 16 here, you'll be calling it as the relative atomic mass of oxygen. And this particular term, that you will be calling it as the actual mass of oxygen. Quickly, let me know in the chats if every single thing is clear till here. With the thumbs ups, people. Everyone in the chats, quickly, if all the things are clear to everyone. Quickly, my dear students, yeah? So the first concept of atomic mass, I think it is done and dusted. It's damn clear to everyone. Now, one thing I would want you all to do. What is that? You just have to remember atomic masses of some element. Just do that. Just do that. Okay? Atomic masses of some elements. Now, you must be thinking which all elements sir is talking about. Just do remember the atomic mass of certain elements starting from hydrogen till zinc. The first 30 elements, their atomic masses you have to remember. That's all. That's all, right? Perfect? That's all. Yeah? Okay, someone is asking about the notes. Notes you'll be getting on this telegram. t.me/WASSIMSIRCHEM. This is the telegram channel on which you'll be getting the handwritten note, right? Okay, this is the telegram channel on which you'll be getting the handwritten note. Perfect. So I think the first terminology, it's clear to everyone. Let's move on to the second terminology. What is second terminology? It's again very simple. What is it? Molecular mass. Molecular mass. What is molecular mass all about? Tanya, I just told you, just remember the atomic masses from hydrogen till zinc. The first 30 elements, their atomic masses you have to remember. Okay? All right. Second terminology, that is molecular mass. Molecular mass, how do we define it? The sum of atomic masses. The sum of atomic masses. The sum of atomic mass. So first of all, like we defined atomic mass, mass of one atom of an element. In the similar way, you can define this molecular mass. In simple words, you can define it like this. Molecular mass is basically the mass of single molecule. You can define it like this. The mass of single molecule. The mass of single molecule. And how will you calculate it? The sum of atomic mass of all the elements present in. What does that mean? What does that mean? Let's have a look. For example, I'm writing water over here. I'm writing water over here. Let's assume I need to calculate the molecular mass of water. What do I need to do? I need to calculate the molecular mass of water. What does that mean? That means I need to calculate the mass of one molecule of water. That means I need to calculate the mass of one molecule of water. Now, my dear students, this water, it is made up of two different elements, hydrogen and oxygen, right? Hydrogen, its atomic mass is 1 AMU. There are two hydrogen atoms, so multiplied by 2. Oxygen, its atomic mass is 16 AMU, and there is one oxygen atom, right? The value over here comes out to be 18. Now, it's completely your choice. Whether you want to write 18 AMU, or you want to write U, or you want to write D. The choice is all yours. But preferably in the case of molecules, we write U over here. Yeah? So this 18U, can I further write it as 18 multiplied by 1U? Absolutely. 1U is basically nothing. It is 1/12 of the mass of carbon-12 atom. And instead of 1U, can't I write 1.66 into 10 raised power minus 24 grams? Absolutely. Now let's try to understand the meaning of all these terms. What is the meaning of all these terminology? I just wanted to calculate the molecular mass of water. I just wanted to calculate the mass of one molecule of water. And the mass of one molecule of water came out to be 18U. That means one molecule of water is 18 times heavier than 1U. One molecule of water is 18 times heavier than 1/12 of the mass of carbon-12. And this is the mass of one water molecule in. That's all. Simple and basic. For example, I'm writing a term glucose over here. I'm writing a term glucose, right? Let's say I need to calculate the molecular mass of glucose. Let's say I need to calculate the molecular mass of glucose. What does that mean? That means I want to calculate the mass of one molecule of glucose. I need to calculate the mass of one molecule of glucose. The mass of one molecule of glucose. How do you calculate the mass of one molecule of glucose? Just do the sum of atomic masses. Nothing else. Starting with carbon. Carbon has got the atomic mass of 12 AMU. And how many carbon atoms do we have? 6 carbon atoms. Apart from carbon, we have got hydrogen. Its atomic mass is 1 AMU. And there are 12 hydrogen atoms. Similarly, oxygen is present as well, whose atomic mass is 16 AMU. and there are 6 oxygen atoms. My dear students, when you calculate it, when you solve it, what is the value which you'll be getting? You'll be getting the value exactly as 180 U. And this 180 U, I can write as 180 multiplied by 1 U. I can do that, right? I can do that. And instead of this 1 U, you can write all the things. Instead of 1 U, you can write 1/12 of the mass of carbon-12 atom. Instead of 1 U, you can write 1.66 into 10 raised power minus 24 grams. Instead of 1 U, you can write 1 divided by Avogadro's number in grams. All these things you can easily write over. Yeah? Right, people? So, what I was supposed to calculate? I was supposed to calculate the molecular mass of glucose. I was supposed to calculate the mass of one molecule of glucose. And how did I do it? I just did the sum of atomic mass, nothing else. The molecular mass of glucose, it came out to be 180. So, one molecule of glucose is 180 times heavier than 1 U. One molecule of glucose is 180 times heavier than 1/12 of the mass of carbon-12. This is the mass of one molecule of glucose. That's all. Right? Is this super clear to everyone? Let me know quickly in the chats with the thumbs ups. I want the chats to go up continuously. Quickly, my dear students. Is this super clear to everyone? Is this super clear to everyone quickly? Quickly, let me know in the chats. Everyone. If the term molecular mass is clear, that means we can write its definition now. We can write its actual definition. Can I say molecular mass? It is a number. Molecular mass, it is a number which tells how many times a molecule is heavier than 1/12 of the mass of carbon-12 atom. Right? It is again one more definition of the term molecular mass. I hope it is super clear. Right? And dear students, one more thing. Let's have a look on one more thing. For example, I'm taking ammonia into consideration, NH3. NH3. First of all, is it atom or molecule? It's absolutely a molecule, right? NH3. It's a molecule. Now, dear students, I'm writing few terminologies related to NH3. The first terminology, I'm writing 17U. The second terminology, I'm writing 17. Third terminology, I'm writing 17 multiplied by 1.66 into 10 raised power minus 24. Now, what is the meaning of all these three terminologies? You should be knowing the meaning now. Dear students, this 17U, I will be calling it as the molecular mass of NH3. This is something which I'll be calling as the molecular mass of NH3. This 17 only, without the units, I'll be calling it as the relative molecular mass. I'll be calling it as the relative molecular mass of NH3. And dear students, this particular term, the last term over here, I will be calling this as the actual mass of NH3. I'll be calling this as the actual mass of NH3. I hope all these three terminologies are clear to you. Now, if all these three terminologies are clear, then you have to tell me the answer of one simple question. What is that? Have a look. I'm writing oxygen here in the atomic form. And over here somewhere, I'm writing oxygen in the molecular form. The difference is, here I'm taking oxygen in atomic form. Here I'm taking oxygen in molecular form. Dear students, here I'm writing 16 AMU, then I'm writing 16, then I'm writing 16 multiplied by 1.66 into 10 raised power minus 24 grams. And over here, first term I'm writing as 32U, the second term I'm writing only 32, the third terminology I'm writing 32 multiplied by 1.6 into 10 raised power minus 24 grams. You need to tell me the meaning of all these terminology. Tell me the meaning of all these terminology. The first terminology, 16 AMU. What is it? It is basically the atomic mass of oxygen. Since oxygen here is in atomic form. Oxygen here is in atomic form. And here, oxygen is not in atomic form. It is basically in molecular form. It is basically in molecular form, right? This is the difference. That's all. Yeah. This particular term I'm calling as atomic mass of oxygen. And this 16, I'll be calling it as the relative atomic mass of oxygen. And this particular term, I'll be calling it as the actual mass of O. Actual mass of O, correct? What about these terminology? 32U. What is it? It is basically the molecular mass of oxygen. Because here oxygen is in molecular form. 32, relative molecular mass of oxygen. This particular term, actual mass of O2. I hope all these three terminologies are very, very, very clear to you. So let me know once in the chats if all these terminologies are clear so that we can solve your questions. Quickly, guys, everyone. Everyone. Everyone in the chats with the thumbs ups. All clear? All clear, guys? Everyone, quickly. Perfect. Let's try to solve few questions which can be asked out of the two concepts which I've taught you till now. Yeah? Let's see what kind of questions can be asked. Have a look, guys. This is the first question on the screen. And these sort of questions can be asked. The question is, if 1U is defined as 1/24th of the mass of carbon to light, calculate the molecular mass of carbon dioxide on this new scale. So what the question says and how we are going to deal with these. Have a look. First of all, as per the question is concerned, we have to define 1U. We have to define 1U as 1/24th. 1/24th of the mass of carbon to light. Right? This is something. This is how we have to define 1U as per the question. Right? This is how we have to define 1U as per the question. So this is the new scale. This is the new scale as per the question. Okay. What is the scale which we have chosen? We have chosen one scale like this. 1U is nothing. 1/12th of the mass of carbon to light. This is the scale which we have chosen long back. Right? So the first statement over here, it is a new scale. This one is the conventional scale, the old scale. Correct? Right, people? Now, let's call the first equation as equation 1. Let's call this as equation number 2. Let's call this as equation number 2. Always your first step has to be, you need to get the relation between U and U dash. That has to be your first step all the time. Get the relation between U and U dash. Now, dear students, the point is how we are going to get the relation between U and U dash. Just do one thing. Divide these two equations. Divide these two equations. Let's divide equation 2 by equation 1. Equation 2 by equation 1. So it's going to be U divided by U dash. U divided by U dash. Mass of carbon 12, mass of carbon 12 cancel. Here you'll be getting 1/12. Here you'll be getting 1/24. U divided by U dash is coming out to be 2 here. And if U divided by U dash is coming out to be 2, what does that mean? What does that mean? That means U is coming out to be equal to 2 times U. I hope this is clear. This has to be your first step all the time. Get the relation between U and U dash. Okay? Well, after getting the relation between U and U dash, there's one more thing which you need. There's one more thing which you need. What is that? Tell me, what is the molecular mass of carbon dioxide as per the old scale, as per the conventional scale? What about the molecular mass of carbon dioxide as per the old scale, as per the conventional scale? It's going to be carbon 12 plus oxygen 16 multiplied by 2. Value comes out to be 44U. This is basically the molecular mass of carbon dioxide as per conventional scale, as per old scale. But we have to calculate the molecular mass of carbon dioxide as per new scale. That means the answer has not to be in terms of U. It has to be in terms of U dash. That's all. Yeah. So what I'll be doing, This 44u, I'll be writing as 44 multiplied by 1u. And my dear students, already, instead of 1u, I can write 2 times u dash. I can write 2 times u dash. So the final answer of this particular question will come out to be 88 u dash over here. So this is the molecular mass of carbon dioxide as per the new scale which is given to us as per the question. And this was the molecular mass of carbon dioxide as per the conventional scale, as per the... If this is super clear to you, let me know once in the chats with the thumbs ups. Everyone, quickly. Quickly, guys, everyone. Yeah? Perfect. All right. So let's try to solve one more question. Let me see if you can solve this one or not. Can you give it a try? The same procedure which you'll be following in this question as well. You do not have to do something new here. You'll be following the same procedure which I told you. As per this question, if 1u is defined as 1/6 of the mass of carbon-12, we are defining 1u as per the question, 1u is defined as 1/6 of the mass of carbon-12. Okay, as per the question. And how we have defined the u as per conventional scale? That was 1/12 of the mass of carbon-12. That was 1/12 of the mass of carbon-12. Yes, students, let's call this as equation number 1. Let's call this as equation number 2. The first step always is to get the relation between u and u dash. So I'll be dividing the two equations. Dividing equation 2 by equation 1. What do I get? U divided by u dash. U divided by u dash is equal to mass of carbon-12 cancel. Here you'll be writing 1 by 12. Here you'll be writing 1 by 6. So u divided by u dash is coming out to be 1 by 2, or we can say u is nothing. It is just u dash divided by 2. This is something which we got till now. U is equal to u dash divided by 2. Now, students, what is the next step? What do we have to calculate? We need to calculate the molecular mass of NH3 as per the new scale. Now, if I ask you, what is the molecular mass of NH3 as per the conventional scale? Molecular mass of NH3 as per the conventional scale, how much that is? Nitrogen, it's 14 plus hydrogen, it's 1 multiplied by 3. The value will be 17u. But do we have to write the answer in terms of u or u dash? We have to write the answer in terms of, right? So you can write it as 17 multiplied by 1u. And my dear students, instead of 1u, you'll be writing just u dash by 2. So it's going to be 17 multiplied by u dash divided by 2. The final answer will come out to be 8.5 u dash. So this is the molecular mass of NH3 as per what? As per the new scale. Yeah? Perfect. Perfect, people. Now, if you got to know how to deal with these questions, then I would want you guys to write a note. I would want you guys to write a note. What is the note? What is the note? Note is, have a look. This was the molecular mass of NH3 as per the scale which we have chosen in the beginning. This is the molecular mass of NH3 as per the new scale. So if I ask you, on changing the scale, is the molecular mass of the substance changing? Yes. Initially it was 17u, now it's 8.5 u dash. So if you change the scale, molecular mass of the substance, it changes. But do remember, on changing the scale, actual mass does not change at all. Do remember this. Do remember this. Actual mass of NH3 will always remain as 17 multiplied by 1.66 into 10 raised power minus 24. Right? Do take a note of it. Actual mass of a substance. Actual mass of a substance does not change on changing the scale. Okay, this is one important note which you are going to remember from now on. Yeah? Guys, everything clear till here? Quickly. Quickly in the chats, everyone. Everyone, quickly. All clear? You should be telling me if all the things are clear. in the chats with a thumbs up. Yes, I'll be giving you breaks in between. The first break will be at 8. Yeah? EYQs, everything I'll be doing. Just wait, just wait. Try to learn things. Try to understand the concepts first. Get the concepts, all the things will be done here all. You not to worry about it. Okay? Perfect. Let's move on now to one more term. That's something which you call as molar mass. Have you heard about the term molar mass? Have you heard about the term molar mass? You must have heard, right? What is molar mass all about? Molar mass of the substance, it is defined as the mass of 1 mole of a substance. It is defined as the mass of 1 mole of a substance, and it is expressed in grams per mole. Now, what is meant by that? Before going into the molar mass, what is meant by 1 mole of a substance? This is something I assume everyone will be knowing, right? What is 1 mole of substance? If I'm writing a statement, 1 mole of a substance. If I'm writing 1 mole of a substance, what does that mean? That means we have got 6.022 into 10 raised power 23 particles of that substance. Right? If I say I have got 1 mole of a substance, that means I have got 6.022 into 10 raised power 23 particles of that substance. If I say I have got 1 mole carbon, what does that mean? That means I have got 6.022 into 10 raised power 23. Since carbon is in atomic form, so I'll be writing atoms of carbon. As simple as that. Yeah. If I write 1 mole water, what does it mean? It means I have got 6.022 into 10 raised power 23. Here water is in molecular form, so I'll be writing molecules of water. As simple as that. If I say I have got 1 mole marker, that means I have got 6.022 into 10 raised power 23 markers. As simple as that. Okay? Now, dear students, understand and analyze things. Particles can be atoms, particles can be molecules, particles can be ions, anything. Yeah? Class timing every day will be 5 p.m. Okay. Now, people, mass of 1 mole of a substance is something which we call as molar mass. For example, I need to calculate molar mass of carbon. That means I need to know the mass of 1 mole of carbon. Let's say I need to calculate the molar mass of water. What does that mean? That means mass of 1 mole of water. Molar mass of nitrogen, mass of 1 mole of nitrogen. Molar mass of marker, mass of 1 mole of marker. Right? So, in short, what is molar mass? Molar mass is nothing. It is just mass of 1 mole of it. That's all. Right? Now, let's try to understand it a bit more in detail. Yes, students, I'm writing a term over here as molar mass of oxygen. Molar mass of oxygen. O. Oxygen I'm taking in atomic form. Molar mass of O. What does it mean? Molar mass of O. What does it mean? It means I'm talking about the mass of 1 mole of O. Right? Simple. Molar mass of O means mass of 1 mole of O. If I ask you, in 1 mole of O, how many atoms of O will be there? In 1 mole of O, how many atoms of O will be there? Can I write this mass of 1 mole of O like this? Mass of 6.022 into 10 raised power 23, which you call as Avogadro's number. Mass of NaO atoms. Can I say something like this? Both the statements are same. Their meaning is same, right? Now, understand one more thing. Mass of Na oxygen atoms. Mass of Na oxygen atoms. So, can I say, instead of mass of Na oxygen atoms, can I write mass of 1 oxygen atom, multiplied by Avogadro's number? Will it make a difference? All the 3 statements, they are same. Their meaning is, if you say we are calculating mass of 1 mole of oxygen, if you say we are calculating the mass of Na oxygen atoms, or mass of one oxygen atom multiplied by Avogadro's number, all these three terminologies are one and the same. Yeah. Now comes a point. Have a look. Mass of one oxygen atom, we call that as the atomic mass of oxygen. And you know, atomic mass of oxygen, it is nothing, it's 16 AMU. And here, you're writing Avogadro's number. Yeah. The 16 AMU, you can further write it as 16 multiplied by 1 AMU. And here, you know, it's Avogadro's number. And my dear students, in the beginning only, I told you 1 AMU is nothing. It is 1 divided by Na grams. And here you have got Na cancel. The value comes out to be 16. What is the 16? 16 is basically the molar mass of oxygen. And molar mass, it's expressed in grams per mole. What does it mean? What does the 16 grams per mole mean? It means mass of 1 mole of oxygen is 16. Mass of 1 mole of oxygen is 16 grams. If oxygen is taken in atomic form, right? This is the mass of 1 mole of oxygen. Perfect. Now, what was the atomic mass of oxygen? Atomic mass of oxygen was 16 AMU. That means mass of one atom of oxygen was 16 AMU. Molar mass of oxygen came out to be 16 grams. So, do you see the magnitude wise? Both the things are same. It is just the units are different. When you write AMU as the unit, it becomes atomic mass. When you write grams per mole as the unit, it becomes molar mass. Nothing else. Yeah? Perfect. So, let me quickly summarize it. Have a look what I'm going to say. Let me quickly summarize it. Have a look properly, guys, what I'm going to tell you now. For example, I'm talking about carbon. Okay? I am talking about carbon. Yes, students, the first terminology which I'm writing, that's 12 AMU. Second terminology I'm writing as 12. Third terminology I'm writing as 12 into 1.66 into 10 raised power minus 24 grams. Fourth terminology, instead of 12 AMU, I'm writing 12 grams. Yeah, 12 grams per mole. Now, if I ask you whether all these terminologies are same or different, these are different. What is the meaning of all these terminologies? This 12 AMU is something, since carbon here is in atomic form, right? It's in atomic form. So, this 12 AMU, it is the mass of one atom of carbon, and you call that as the atomic mass. This is the atomic mass of this 12 here. This is called as the relative atomic mass of carbon. This particular term, you call this as the actual mass of carbon. And the last term over here, 12 grams per mole. 12 grams per mole. That means the mass of 1 mole of carbon is 12 grams, right? This is something which you call as molar mass of carbon. This is something which you call as molar mass of carbon. This is something which is the mass of 1 mole of carbon, 12 grams, right? Perfect. Now, dear students, whether I have taken carbon in atomic form or molecular form, I have taken carbon in atomic form. So, instead of molar mass, you can use one more term. You can use gram atomic mass. You can call it as gram atomic mass. No issue. Yeah. One more term. For example, I'm writing NH3 now. Let's say I'm writing NH3. I'm writing few terminologies related to NH3. Let's see what it means exactly. First terminology I'm writing as 17U. Then I'm writing only 17. Then I'm writing 17 multiplied by 1.66 into 10 raised power minus 24 grams. Then I'm writing 17. Instead of U, I'm writing grams per mole. Grams or grams per mole. Okay? So whether the meaning of all these things is same or different. First of all, NH3 here, it is not in atomic form, it's in molecular form. Right? It's a molecule. Yeah? Now, the 17U is what you'll be calling as the molecular mass. Molecular mass. This 17 is something which I call as relative molecular mass. This particular term, I will be calling it as the actual mass. Right? And this particular term, I'll be calling it as the molar mass of NH3. This is the molar mass of NH3. Now, dear students, one more thing. Since NH3 is taken in molecular form, So instead, the term molar mass, should I be writing gram atomic mass or gram molecular mass? You can call it as the gram molecular mass as well. Now, if all these terms are clear to you, do let me know once in the chats with the thumbs ups. Quickly. Quickly, guys. Everyone in the chats with the thumbs ups, quickly. Perfect. All right, guys. Perfect. So if this is clear to everyone, then let's try to solve one basic question. Basic question. You guys are going to solve it. What do you think about this question? Quickly. You guys are going to solve this question. Give it a try. Give it a try, people. Give it a try quickly. The mass of one atom of X is given. The mass of one atom of X is given. We need to calculate the molar mass of X. We need to calculate the molar mass of X. So, my dear students, what is meant by molar mass of X? Molar mass of X means the mass of 1 mole of X, right? Molar mass of X means mass of 1 mole of X. What is meant by mass of 1 mole of X? Mass of 1 mole of X means mass of NaX atoms, right? Mass of NaX atoms. I'm writing it. Mass of NaX atoms. Now, dear students, few minutes back only I told you how to write this particular state. Mass of NaX atoms means the mass of one X atom. The mass of one X atom multiplied by what? Multiplied by Avogadro's number. Simple, right? Now, the mass of one X atom is given to us. It's 4 into 10 raised power minus 23 grams. Multiplied by what? Avogadro's number. 6.022 into 10 raised power 23. So, this term got cancelled. 6 4s comes out to be 24 and its units are going to be in grams. So, this 24 grams is basically the molar mass of X. This is the mass of 1 mole of X. 1 mole of X has got the mass of 24. In short. So, from now onwards, if you will be given with the mass of one atom of element, just multiply the mass of one atom of element by the Avogadro's number. By the Avogadro's number, you'll be getting the molar mass. And molar mass, it's expressed in grams, you know it. Yeah? Perfectly done? Perfectly done? All right, people. Wonderful. So, I hope all the 3 terminologies which I told you till now, I hope all these 3 terminologies are clear. Now, let's have a look on one more important topic, that is average atomic mass of an isotopic mixture. This is again one important topic from which question. Okay. So, first of all, if I ask you what the isotopes are, what are isotopes? How do you define the term isotope? How do you define the term isotope? Isotopes are nothing. These are the atoms. These are the atoms of same element. Atoms of same element. Having same atomic number but different atomic mass. This is something which every one of you would be knowing, right? Isotopes are the atoms of same element having same atomic number but different atomic. Now guys, what it means exactly. If you talk about your hydrogen, right? Every one of you must be knowing hydrogen, it has got 3 atoms. Hydrogen has got 3 atoms which have got same atomic number, but their atomic masses are different. This is 1, this is 2, this is 3. Can I say these are the 3 atoms of the same element which have got same atomic number but different atomic masses? Absolutely. So I'll be calling these 3 atoms. As the isotopes of hydrogen. As simple as that. I'll be calling them as the isotopes of hydrogen. Similarly, dear students, if you talk about, for example, chlorine. Chlorine has got 2 atoms. Which have got same atomic number. But their atomic mass is different. This is 35. This is 37. So can I categorically say these are basically the atoms of chlorine which have got same atomic number but different atomic masses? Absolutely. So again, these 2 atoms I will be calling as the isotopes of. I'll be calling them as isotopes of chlorine. So what are isotopes? Isotopes are just the atoms of same element having same atomic number but different atomic mass. As simple as that. Okay. Now, dear students, let's try to understand the important terminologies related to isotopes. Yeah, and do remember them. For example, I'm taking an element X. Okay, this is the element which I'm assuming this X has got 3 atoms. Which have got same atomic number, which I'm representing with Z, but different atomic masses. This is M1, this is M2, this is M3. Can I say these are the 3 atoms of X which have got same atomic number but different atomic masses? Absolutely. So I should be calling these 3 atoms as the isotope. Now people, whenever the element exists in isotopic forms, whenever the element has isotopes, do remember, whenever the element has isotopes, we do not calculate the normal atomic mass for that element. What do? We calculate average atomic mass of that particular. Whenever the element exists in the form of isotopes, we do not calculate the normal atomic mass of the element. What do we calculate? We calculate the average atomic mass of it. And in order to calculate the average atomic mass of an element, what do we need? We need percentage abundances. Or we need mole percentage of these isotopes. What these percentage abundances and mole percentage are all about, you'll get the idea in some time. First of all, remember what I'm saying. Whenever the element exists in the form of isotopes, what do we calculate for that element? We calculate average atom. And in order to calculate the average atomic mass, what do we need? We need the percentage abundances of these isotopes. I'm assuming the percentage abundances of these isotopes I'm representing with A, B, and C. My dear students, once you get the percentage abundances of these isotopes, once you get the mole percentage of these isotopes, you just have to have one formula. What is the formula? Formula is M1A. Plus M2B plus M3C divided by A plus B plus C. This is the general result by means of which you can calculate. The average atomic mass of an element has got isotopes. Okay. Now the point is, what is meant by these percentage abundance? Before talking about the meaning of the percentage abundance, let me tell you one more state. Do remember the sum of percentage abundance. Of all the isotopes. Of a particular element. of a particular element. That's always equal to 100. What does that mean? That means A plus B plus C plus whatever are given is always equal to. Right? Now let me make you understand. Let me make you understand exact meaning of all these. Let's have a look what it means. For example, I'm talking about chlorine. I'm talking about chlorine for you. Okay? Just a second, guys. Just a second. Yeah. For example, I'm talking about chlorine. We know chlorine has got okay. So right here, I'm talking about chlorine, and we know chlorine has two isotopes. One is Cl35, another one is Cl36. Right? These are the two atoms of chlorine which have got same atomic number but different atomic. Yeah. So, my dear students, I'll be calling these atoms as the isotopes of chlorine. So, if chlorine has got isotopes, do I calculate the normal atomic mass of chlorine? No, I do not calculate the normal atomic mass. What do? I will be calculating the average atomic mass. And you must be knowing, in order to calculate the average atomic mass of chlorine, what do I need? What do I need? I need the percentage abundances of these isotopes. And let me tell you, the percentage abundances of these isotopes of chlorine are 75 and 25 respectively. Okay. These percentage abundances, we represent them with A and B. This is the value of M1 and this is the value of M2. So first of all, you must be thinking what these percentage abundances are all about. Since, my dear students, you know, in nature, chlorine exists. Chlorine exists in the form of Cl35 as well as in the form of Cl37. You know that. In nature, chlorine exists in the form of Cl35 as well as Cl37. Do remember, 75% of the chlorine atoms in the nature, they will be existing in the form of Cl35, and the remaining 25% of the chlorine atoms will be present in the form of. That is the percentage. That is the percentage abundance. I'm giving you the percentage abundance of these isotopes. That means 75% of the chlorine atoms in nature, they will be present in the form of Cl35, and the remaining 25% will be present in the form of. Now, my dear students, since chlorine has isotopes, if the element has isotopes, what do? Do we calculate normal atomic mass? No. Calculate average atomic. What is the formula to calculate average atomic mass? It's M1A plus M2B divided by what? Divided by A. Now, if I ask you, what is the value of M1? M1 value is 35. What is the value of A? 75. What about the value of M2? 37. B, 25. And A plus B value, that's always equal to 100. So when you solve it in this equation, you'll be getting the value exactly as 35. So if I ask you, what this 35.5 AMU is all about? Is it the normal atomic mass of chlorine? No, it is not the normal atomic. It is the average atomic mass of chlorine which we are calculating, right? This is the average atomic mass of chlorine. Perfect. So do remember, whenever the element exists in the form of isotopes, we do not calculate the normal atomic mass of the element. We always calculate the average atomic mass of an element. And in order to calculate the average atomic mass of an element, what do we need? We need the percentage abundances or mole percentage of these isotopes. Once we get the percentage abundances or mole percentage of the isotopes, then you can directly use this particular result and get the average atomic mass of an element which exists in the form of what? Which exists in the form of ion. Yeah? Perfect. Now, they can just modify the question basically. This was one question which I gave you, right? They can modify the same question. They can modify the same and and they can form a question like this. They can form a question like this. It's not mandatory that percentage abundances will be given to you, right? They can also ask you how to calculate the percentage abundance. Have a look how. For example, you have got a question like this. You have got the element X. It has got two isotopes. One is X35, one is X37. As per the question, the average atomic mass of X is 35.5 AMU. We need to calculate the percentage abundances. We need to calculate the percentage abundances of these two isotopes. Can't we do it? Can't we do it? Element X, it has got two isotopes. Average atomic mass of element is given. We need to calculate the percentage abundance of these isotopes. Now, my dear students, have a look how we are going to solve these questions over here. Understand. First of all, this 35 is something which I call as M1. This 37 is here M2. Okay. Few minutes back I told you the sum of percentage abundances of all the isotopes of a particular element, that's always 100. I told you the sum of the atomic masses of all the isotopes of a particular element, that's always 100, right? So let's assume the percentage abundance of the first isotope, that's X. So the percentage abundance of another isotope, that has to be 100 minus X. Okay? And percentage abundances, how do we represent them? We represent them with A and B. That's all. M average. Instead of M average, can't I write M1A plus M2B divided by A plus B? Right? And this value, as per the question, is 35.5. M1 value is given to us as per the question, 35. A value is X. M2 value 37. B value is 100 minus X. Divided by what? Divided by A plus B, that's always 100. And this value will be 35. Correct? Simple. Simple. So, my dear students, if you just do the cross multiplication, you'll be getting the value of X from here. And the value of X will come out to be 75%. And what was this X? X was basically the value of A, which is the percentage abundance of X35. Which is the percentage abundance of X35. So, if I ask you what is the percentage abundance of X37? Percentage abundance of X37, that's B. And what was B? B was nothing, it was 100 minus X. So 100 minus 75 comes out to be 25%. I hope it's super clear to everyone. Quickly, let me know in the chat with the thumbs up. Quickly, everyone people. Everyone. Is it super clear to everyone quickly? Quickly with the thumbs ups, everyone. Perfect. Perfectly done. All right. Let's try to solve one more question so that this concept becomes properly clear to you. There was one question which was asked long back from the same concept, right? And see what kind of simple question was asked in your NEET exam. Look at the question given. Look at the question given. The question is, we are given with boron. We are given with the element boron. And as per the question, boron has got two isotopes. One is boron 10 and another one is boron 11. Correct? As per the question, the percentage abundance of boron 10, it's given to us as 19. And percentage abundance of boron 11, it's given to us as 81. What are we supposed to calculate? We are supposed to calculate the average atomic mass of boron. MAV we have to calculate. Average atomic mass of boron. So dear students, this is something I'm calling as M1. This is something I'm calling as M2. This is the value of A and this is the value of B. Just use the formula, nothing else. I'll be using M1A plus M2B divided by what? Divided by A plus B. So in order to calculate MAB, I'll be using M1 is given to us as 10, A value is 19, M2 value that's given to us as 11, B value that's 81 divided by A plus B will be always 100. Just a matter of calculation and get the final answer. That's all. Nothing else. Yes, if you want to join the Avengers batch, there's a code Avenger which you have to use. AVENGER. So people are saying final answer of this particular question is coming out to be 10.81 AMU, which will be absolutely the correct answer. Majority is saying, yeah, shortly. Okay. Perfectly done. All right. One more question which I'm giving you. Let me see if you can solve this question or not. For example, you have got a question like this. The question is, we have got the element X. We have got the element X. Or let's talk about directly the magnesium. We have got the element magnesium. Magnesium, for example, it has got 3 isotopes. One is Mg24, one is Mg25, and one more is Mg26. These are the 3 isotopes of magnesium. Okay. As per the question, the percentage abundance of Mg24 that's given to us as 79. This is the percentage abundance of Mg. And at the same time, the average atomic mass of magnesium. The average atomic mass of magnesium is given to us as 24.31 AMU. Now, as per the question, we are supposed to calculate the percentage abundances of the remaining 2 isotopes. Can you do it? Can you do this question, guys? Can you do this question quickly? The ones who have not subscribed to the channel yet, I would want everyone to subscribe to the channel right now. And the ones who have not liked the session yet, please do like the session. Make the live count to 1K, 913 something. Yeah? Let's make the live count as well as number of likes to 1K. Quickly. Quickly. It's not increasing. Why is that? All right, people. So let's have a look exactly how this sort of a question I'm going to solve here. Understand? First of all, we know the sum of the percentage abundances of all these isotopes, that has to be 100. The sum of percentage abundances of all these isotopes of magnesium, that has to be 100. Okay. So people, just understand one thing. The percentage abundance of the first isotope is 79. That means what will be the percentage abundance of the remaining 2 isotopes? The percentage abundance of the remaining 2 isotopes, that has to be 21, because the sum eventually has to be 100. The sum eventually has to be 100. The percentage abundance of the first one is 79. That means the percentage abundance of the remaining 2 isotopes, that has to be 21. So out of that 21 percentage, let's assume the first isotope has got the percentage abundance of X. So the second one has to be, it has to be 21 minus. I hope this particular step is clear to everyone. I hope this particular step is clear to everyone. The first isotope, its abundance is 79. The second one, it's X. The third one, automatically, it has to be 21. Okay. This particular term, 79, I'm representing with A. This term, I'm representing with B. And this term, I'm representing with C. 24 is the value of M1. 25 is the value of M2. And 26 is the value of M3. Now, dear students, instead of MAV, can't I write M1A plus M2B plus M3C divided by A plus B plus C? That value is already 100. And this overall value is 24. M1 value, that's 24. A value, that's 79. M2 value, that's 25. B value, that's X. M3 value, that's 26. C value, that's 21 minus X divided by A plus B plus C, that's 100. And this overall value is equal to 24. Yeah. Now, again, it's a matter of calculation. Again, it's a matter of calculation. You just have to cross multiply things over here and you'll be getting the value of X. And X value, as far as I remember, X value will come out to be 11. And what was this X exactly? X was basically the percentage abundance of Mg25. This was the percentage abundance of Mg25. Now, if you ask me, what will be the percentage abundance of Mg26? That's 21 minus 6. That's 21 minus 6. 21 minus 11. That means the percentage abundance of the remaining 2 isotopes we got to know came out to be 11. So quickly in the chats, if everything seems clear till here. Quickly, people. Everyone. Everyone. Quickly. Quickly, guys. Everyone in the chats. I hope all these questions you can easily solve from now on. Okay? Perfect? Perfect? All right. So, now let's move on. Something called as calculation of mole. Dear students, now we are going to enter into the actual mole concept. So till now I was talking about some basic things which are required in the chapter. Now I'm going to actually enter into the chapter. So first of all, I'll let you know how many different ways are there by means of which you can calculate number of moles. Okay, have a look, people. Over here I'm writing the terminology as the number of moles. The number of moles. Number of moles are represented by N, and there are many ways by means of which we can calculate number of moles per particle. How exactly? Number of moles of the substance is always equal. Given mass of the substance in grams divided by molar mass of the substance in grams per. This is the first expression by means of which we can calculate first expression. Given mass of the substance divided by mole. The second way to calculate the number of moles of the substance, that's equal to given number of particles of the substance divided by what? Divided by Avogadro's number. This is one more result by means of which you can calculate given number of particles of a substance divided by Avogadro. My dear students, the third result to calculate number of moles. The third result to calculate number of moles is only valid for gases. And the gas has to be present at STP. And STP already you must be knowing. STP means standard temperature pressure. Standard temperature pressure. When the gas is kept at the pressure of 1 atm and its temperature is kept as 0 degrees centigrade, right? When you'll be having a gas in the container, whose pressure will be 1 atm, whose temperature will be 0 degrees centigrade, then only we say the gas is present at STP. Now, whenever you'll be having a gas which will be present at STP, how do you calculate its number of moles? It's always equal to given volume of the gas in liters divided by 22.4 liters. Or if you take the given volume of the gas in milliliters, then you have to divide it with 22400. Okay, these are few basic results by means of which we can calculate number of moles. Given mass of the substance divided by molar mass of the substance. Number 2, given number of particles of the substance divided by Avogadro's number. Number 3, given volume of the gas in liters divided by 22. So these three basic results, let's exactly see how they are to be applied. How these results are applied in basic. For example, one simple question here. Calculate the number of moles present in 160 grams of NaOH. Imagine that you have got a container which contains 160 grams of NaOH, and I am asking you that how many moles of NaOH are there in the container? What will be your answer? You will say mass of substance is given. And we have to calculate moles of substance. How do you convert mass into moles? It's given mass divided by molar mass. Given mass of substance is 160 grams divided by molar mass of NaOH, 23 plus 16 plus 1. The value comes out to be 40 grams per mole. So what is the final answer? The value comes out to be 4. Now it's completely your wish. Whether you want to say that you have got 160 grams of NaOH in the container, or you can say directly that you have got 4 moles of NaOH in the container. The choice is all yours. No worries at all. Right? You can say we have got 160 grams of NaOH in the container. Or you can say we have got 4 moles of NaOH. Look at the second thing. Calculate the number of moles present in 67.2 liters of carbon dioxide at STP. Now, if you ask me, since you have got 67.2 liters of carbon dioxide gas in the container, how many moles of carbon dioxide are there in the container? How many moles of carbon dioxide are there in the container? Check first of all, are we given with the mass of substance or volume of substance? We are given with the volume of substance. We are given with the volume of substance, right? Perfect. And how do you convert volume into moles? It is given volume of gas in liters, which is 67.2 liters divided by 22.4, the value comes out be. Now it's completely your wish whether you want to say that you have got 67.2 liters of carbon dioxide in the container, or you can say you have got 3 moles of carbon dioxide. The choice is. Look at the next one. We are given with the atoms of carbon, right? There are, for example, these many atoms of carbon in the container. And I am asking you, how many moles of carbon are there in the container? You will say, given number of particles divided by Avogadro's number. Given number of particles are 24 into 10 raised power 23 divided by Avogadro's number. The value comes out to be approximately 4. So whether you want to say that you have got these many atoms of carbon in the container, or you can say you have got 4 moles of carbon in the container. The choice is all yours. Again, you are given with the molecules of water in the container. You have got these many molecules of carbon in the container. Molecules again means particles only. So you are given with the particles of the substance. Convert the particles into moles. So let's calculate number of moles of water, which will be equal. Given number of particles divided by what? Divided by Avogadro's number. The value comes out to be exactly how much? Comes out to be 80. Right? It comes out to be 80. Perfect. So whether you want to say you have got these many molecules of water in the container, or you can say you have got 80 moles of water in the container, the meaning of both the things. Now, if I ask you, how many ways do we have to calculate number of moles of the substance? Till now, what we have learned? We have learned 3 things. If mass of the substance is given, divide the given mass of the substance by the molar mass. If number of particles of the substance are given, divide the given number of particles by the Avogadro's number. If volume of the gas at STP is given in liters, divide the given volume of the gas in liters by 22.4 liters. You'll be exactly getting the number of moles of the gas, right? I hope it's clear to everyone. Right? I hope it's clear to everyone. All right, people. Some more basic questions which we need to solve first. And in order to solve those basic questions, we should exactly know what the mole conversion diagram is. Right? What the mole conversion diagram is. Have a look. My dear students, here I am writing the term number of moles. I am writing the term number of moles. Now, if you ask me how many ways are there to calculate number of moles of the substance, I'll say there are 3 ways. Either will be given with the mass of the substance in grams, or will be given with the volume of the gas in liters at STP, right? Or will be given with number of particles of the substance. These are the 3 ways which can be given, and accordingly, we'll be using the formula to calculate number of moles of the substance. Correct? Now, my dear students, if mass of the substance is given and you have to calculate number of moles, what do we have to do? Divide the given mass of the substance by the molar mass of the substance. You'll be getting the value of number of moles, right? If I do the reverse, if number of moles of the substance are given and we have to calculate mass, if moles are given and we have to convert moles into mass, what do? I'll multiply moles by the molar mass of the substance. Okay? To get what? Get the mass of the substance. Similarly, if number of particles of the substance are given I'll be dividing the number of particles by the Avogadro's number, and I will be getting the number of moles of the substance. Or if moles are given and particles are to be calculated, then moles multiplied by Avogadro's number. Okay. Similarly, if volume of the gas at STP is given, then divide the given volume of the gas by 22.4 liters, you'll be getting number of moles. And if moles are given, just multiply it with 22.4 liters, you'll be getting the volume. This is one simple diagram which will, by solving this particular diagram, by following this diagram, some basic questions related to mole concept, related to basic mole concept can be easily done and done. Okay. Now, how to use this diagram, that is the point. That is the point. How to use this diagram. See guys, given mass divided by molar mass, that gives me moles. Moles multiplied by molar mass, that gives me mass. Okay, simple. Number of particles divided by Avogadro's number, that gives me moles. Moles multiplied by Avogadro's number, that gives me particles. Given volume divided by 22.4, moles. Moles multiplied by 22.4. Guys, I'm not going to give you any sort of break now. We'll be taking the break exactly at, what is the time now? We'll be taking the break at 8. Okay, not now. Yeah? Perfect. Do you know how this diagram, how this conversion diagram came? See guys, it's simple. Look at the first result. Look at the first result. I told you already, if the mass of substance is given, divide the given mass by the molar mass, you'll be getting moles. Or if moles are given, multiply the moles by the molar mass, you'll be getting the mass. That's what I told you. Correct? Similarly, number of particles by Avogadro's number, you'll be getting moles. Moles multiplied by Avogadro's number, you'll be getting the number of particles. Nothing else. Yeah? Nothing else. I hope whatever I'm telling you, that's clear. Now, my dear students, how to use the diagram. Look at these basic. Calculate the mass of 67.2 liters of carbon dioxide at STP in grams. Look at the question carefully. Calculate the mass. We have to calculate mass of 67.2 liters of carbon dioxide. So we are given with 67.2 liters of carbon dioxide, and we have to calculate the mass of 67.2 liters of carbon dioxide, right? Correct? That's something which we need to calculate. We have to calculate the mass of these many liters of carbon dioxide. Now, what you exactly need to do, have a look, understand properly what I'm going to do. First of all, you identify what is given to us. We are given with the volume of the gas. What we are supposed to calculate? We are supposed to calculate. We are given with volume, we are supposed to calculate mass. So, we are given with volume and we are supposed to calculate mass. Is there any direct relationship between volume and mass? There is no direct relationship between volume and mass. There is no such direct arrow between volume and mass. So what I'll be doing? We are given with the volume. We are supposed to calculate mass. So I will be starting with the volume. I'll be starting with the volume and I will have to reach at mass. Whatever arrows will take me from volume to mass, I'll be following all those arrows. So this is the first arrow which I'll be following. This is the first arrow which I'll be following. From here to here, then from here to here. This has to be the second arrow. This has to be the second arrow which I'll be following. Perfect. So two steps are there. I'll be starting from volume and I'll have to reach the mass. So start with volume, follow this arrow, then follow this arrow. So how many steps? Two steps. First step, convert volume into moles. Then convert moles into mass. That's all. So the first step is number of moles of carbon dioxide, which is equal to given volume of carbon dioxide in liters divided by 22.4. The value comes out to be 3. So we have calculated the moles. We have divided the given volume by 22.4. We got the moles. Now moles multiplied by molar mass. That gives you what? That gives you the mass of carbon dioxide. So mass of carbon dioxide in grams will be equal to moles of carbon dioxide multiplied by molar mass of carbon. Now, dear students, moles of carbon dioxide we have calculated 3, and molar mass of carbon dioxide, all of you must be knowing, that's 44 grams per mole. The value comes out to be how much? It will be 130. So 132 grams is basically the mass of 67.2 liters of carbon. That's simple. Look at the second question. Check first of all what is given. we are given with the mass of carbon dioxide. And what are we supposed to calculate? We are supposed to calculate the number of molecules. So in this question, mass is given, particles are to be calculated. Mass is given, particles are to be calculated. Mass is given in this question now. In the second question, mass is given and particles are to be calculated. So I will be starting from mass and I will have to reach to the particles. Whatever arrows will take me from mass to particles, I'll be following them. Mass to particles. So first, this is the arrow which I'll be following, right? Second, this is the arrow which I'll be following. Then only I'll reach from mass to the particle. So how many steps? 2 steps. First step, given mass divided by molar mass of the substance, that gives me moles. Moles multiplied by Avogadro's number, that gives me the number of particles of substance. So 2 steps are there. Let's have a look. 2 steps are there. First step is convert given mass into moles. Given mass divided by molar mass, that gives me the number of moles. So my first step is number of moles of carbon dioxide, which will be equal to given mass of carbon dioxide in grams divided by molar mass of carbon dioxide, which is 44 grams per mole. The value comes out to be 10. So first step is done. Moles are done, right? Now we know moles multiplied by Avogadro's number, that gives me the number of molecules. So I'm writing number of molecules. Number of molecules of what? Number of molecules of carbon dioxide, which will be equal to moles of carbon dioxide multiplied by Avogadro's number. Moles of carbon dioxide means 10 multiplied by what? Multiplied by Avogadro's number. So these many molecules of carbon dioxide we have present in 440 grams of. I hope this is super clear to you, right? I hope it is clear to everyone. Can you let me know the answer of this question quickly? This is again a simpler one. Quickly let me know its answer. Quickly let me know its answer. Calculate the volume of 128 grams of carbon dioxide at STP in liters. Quickly, everyone. Volume of 128 grams of carbon dioxide. So we are given with what? We are given with mass and we have to calculate volume. So convert mass into moles first, then convert moles into volume. Correct? You can do this. You can do this. First step will be number of moles of carbon dioxide will be equal to given mass of carbon dioxide in grams divided by molar mass of carbon dioxide. What do we get? We'll be getting moles of carbon dioxide. Once you get the moles, volume of carbon dioxide will be moles of carbon dioxide multiplied by 22.4. The answer is going to be in liters. That's all. That's all, right? Correct? Correct? Is it clear, guys? Can you solve these sort of questions? Can you solve these sort of questions quickly in the chats? Can you solve these sort of questions quickly? If you can solve these sort of questions, then you should be able to solve this one as well. For example, I'm writing the question like this. The question, for example, is like the mass of one atom of element X is equal to 4 into 10 raised power minus 23 grams. Calculate the number of moles. Calculate the number of moles present in 96 kg of X. Can you solve this question? Can you solve this question quickly? It's a simple question, guys. The mass of one atom of element X is given and we are supposed to calculate number of moles present in 96 kg of X. We have to calculate number of moles present in 96 kg of X. So mass of X is given, which is 96 kg. So it is 96,000 grams. So whenever mass of substance is given and you are supposed to calculate the moles. Given mass, divide by what? Divide by molar mass of X, right? Well, do we know the molar mass of X? We do not know the molar mass of X. But what is meant by molar mass of X? Molar mass of X means mass of 1 mole of X. How do you calculate the molar mass? Mass of one atom multiplied by Avogadro's number. Mass of one atom multiplied by what? Multiplied by Avogadro's number. That gives you the molar mass. And units of molar mass now are going to be in grams per mole. So this term got cancelled, right? Grams got cancelled. So it's going to be 96,000 divided by 6 4s are 24. So the value comes out to be 4,000, right? 400. 4,000 moles. Perfect. So what did we calculate here? We got to know in 96 kg of X. 96 kg of X means 4,000 moles. I hope again this sort of a question you can easily solve from. Yeah? Is it clear? Is it clear to everyone? We were not given with the molar mass of X. But I've already told you, molar mass is nothing. It's mass of one atom multiplied by Avogadro's number. That gives you the mass of 1 mole of element. And mass of 1 mole of element is something which you molar mass of. As simple as. Quickly, if it is clear, let me know once in the chats. Let me know once in the chats. Quickly. Yeah? Okay. I'm giving you one more question. Let me see if you can solve this one or not. Let me see if you can solve this one or not. The question is, how many moles of electrons weighs 1 kg? How many moles of electrons weighs 1 kg? You have to understand the language of the question. How many moles of electrons weighs 1 kg? So what do we have to calculate? We have to calculate what? We have to calculate moles of electrons. What are we given with? We are given with the mass of the substance. How do you convert mass into moles? How do you convert mass into moles? You'll be writing number of moles of electrons is equal to given mass of electrons in grams divided by molar mass of electron. Simple, right? What is the given mass? That is 1 kg. 1 kg means 1000 grams. So this is the given mass of the substance divided by molar mass of electron. Molar mass of electron means mass of 1 mole electron. Mass of 1 mole electron means mass of 1 electron multiplied by 6.022 into 10 raised power 23 multiplied by Avogadro's number. Then only I'll be calling the whole denominator now as molar mass, which is expressed in grams per mole, right? So grams cancel, moles comes up, and you just need to solve this equation and get the number of moles of electrons which actually weighs 1 kg, right? Is it clear to you? Quickly, guys, is it clear to you? Can you solve these sort of questions from now on? You should be able to solve these sort of questions easily. You should be able to solve these sort of questions easily. Okay, one more question. Let me see if you can do any sort of mistake here in this question. The question is, calculate the total number of molecules. Calculate the total number of molecules present in 1.8 liters of H2O. 1.8 liters of H2O liquid. Can you give it a try? Can you solve this question? Calculate the total number of molecules present in 1.8 liters. Total number of molecules present in 1.8 liters of water. And here H2O is present in liquid state. My dear students, you must be thinking that volume is given and we are supposed to calculate molecules, means particles. Volume is given, particles is to be calculated, right? That's something which you must be thinking. Something which you must be thinking, that volume is given and particles are to be calculated. Volume is given and particles are to be calculated. So you will be starting from volume, you will have to end at particles. So you must be thinking that you'll be following this arrow first, then you'll be following this arrow. If you are thinking like this, that means you'll make the question. The question will be wrong. Why is that? Why is that? The first formula, given volume divided by 22.4 liters, which gives you number of moles. That's only valid for what? That's only valid for gas. And the gas has to be present at STP. But are we given with the gas or we are given with the liquid? We are not given with the gas. We are given with, right? So you cannot divide this volume by 22.4, right? You cannot do that. That's only valid for gases. Here it's not gas. Water, it's present in liquid state. So how will I solve this question? Simple. See guys, you must be knowing density of water. Density of water everyone is knowing. How much is that? 1 gram per ml. Correct? Instead of density of water, can I write mass of water in grams divided by volume of water in ml? And this value is given to us as 1 gram per ml. Right? So can I say mass of water in grams divided by volume of water in ml? Volume of water in ml, that means 1800 ml. 1800 ml. And this term is basically equal to 1 gram per ml. Perfect. So from this equation, can't I calculate the mass of water in grams? Mass of water in grams, it's coming out to be how much? 1800 grams. So basically, what are we given with? We are actually given with 1800 grams of water. We are actually given with 1800 grams of water. Correct? Now, dear students, we converted volume into mass. Now, imagine that as if we are given with the mass of substance and we are supposed to calculate molecules. Imagine we are given with the mass of substance and we have to calculate molecules. How do you convert mass into molecules? So first, mass into moles, then moles into molecules. That's it. Right? So, number of moles of water will be equal to given mass of water in grams divided by molar mass of water. The value is 100. Moles we got. Now the molecules. I can say number of water molecules will be equal to moles multiplied by what? Multiplied by Avogadro's number. Right? That's something which we were supposed to. Is this clear to everyone? Quickly. Quickly, guys, everyone in the chats. Everyone in the chats. If this is super clear to everyone. What I told you, whenever the given substance is not in gaseous state, it is in liquid state, then convert its volume into mass by using the term density. Density of water is 1 gram per ml. Density means mass by volume. That's 1, right? Volume is given. So mass of water we got, right? So imagine as if we are not given with the volume of substance. We are given with the mass of substance. So mass of water we got, we have to calculate molecules. So you will start from mass. You will have to reach to molecules in that diagram. So first mass divided by molar mass, that gives me moles. Moles multiplied by Avogadro's number, that gives me what? Molecule. That's all. Yeah? Perfect. Quickly, guys, let me know in the chats with the thumbs ups if it's again clear to everyone. Quickly. Quickly, guys, everyone with the thumbs ups if it is super clear to you. Quickly. Anya, this is enough. Whatever I'm teaching right now, this is enough. This is more than sufficient. No need to go for anything else. Guys, quickly let me know in the chats with the thumbs ups, everyone, so that I'll move ahead. Sleeping somewhere? Quickly, everyone. Avogadro's number value you have to take as 6.022 into 10 raised power. Right now, I'm just taking it as be involved in brutal calculations. Yeah. Let's move on then, guys. Let's move on. There is one more special type of question, which is again simple, in which they'll ask you to calculate atoms, electrons, number of protons, neutrons, ions, all these things they can ask. Whenever you see a question in which they ask you about the electrons, in which they ask you about the atoms, in which they ask you about the protons, neutrons, ions, etc., you'll be again doing one thing. What is that? You'll be using one simple diagram. What is that diagram? Have a look. The diagram is like, I'm writing here, given quantity. Whatever is given to us as per the question, be it mass of substance, be it volume of substance, particles, whatever is given to us as per the question, that's something which you'll be calling as given. Our first step always will be there to calculate number of moles of, to convert the given quantity into moles. That should be always our first. Convert the given quantity into moles. Right? Yes. Convert the given quantity into number of. Given quantity can be in terms of mass, it can be in terms of volume. And you know how to convert mass into moles, you know how to convert volume into moles, right? Everything is already clear. Once you get the moles, if the given substance whose quantity is given to us, if that given substance is in molecular form, then multiply the moles by the Avogadro's number, you will be getting the number of molecules. What does that mean? You'll get the idea in some time. First of all, you remember, if the given substance is in molecular form, then on multiplying moles by Avogadro's number, you'll be getting the molecule. Okay? Once you get the molecules, you can easily calculate atoms, you can calculate electrons, you can calculate protons, you can calculate neutrons, you can calculate ions. Anything can be asked out of these. Anything can be asked. For example, guys, how to use this diagram basically. For example, I'm writing one simple question. I'm writing calculate the total number of atoms. Calculate the total number of atoms present in 448 liters of carbon dioxide at ST. Read the question carefully. What are we supposed to calculate? We are supposed to calculate the total number of atoms present in 448 liters of carbon dioxide at ST. So what are we supposed to calculate basically? We are supposed to calculate atoms. Whenever atoms are to be calculated, that means we'll be using this diagram. Now, look at the question carefully. Whatever is given to us, are we given the volume of the substance? Yes, volume of the substance in liters is given. Volume of the gas in liters is given. What is the first step? This is my given quantity. Convert the given quantity into number of moles. My first step is to calculate number of moles, which will be equal to given volume of carbon dioxide in liters divided by 22.4 liters. The value comes out to be 20. Correct? So we calculated the number of moles of the substance. Now, my dear students, check whether the given substance is in atomic form or molecular form. The given substance is in molecular form, it's carbon dioxide. And you know, when moles are multiplied by Avogadro's number, now we'll be getting the molecules because the given substance is in molecular form. So I'll write number of molecules of what? Carbon dioxide is equal to moles multiplied by Avogadro's number. Moles multiplied by Avogadro's number. So these many molecules of carbon. So we have calculated the molecule. After calculating the molecules, now you can calculate the atom. And how you can convert molecules into atoms. How you are going to convert molecules into atoms. My dear students, since we have done the question till here, now we have to calculate atoms. Can I simply say one molecule of carbon dioxide contains, one molecule of carbon dioxide contains how many atoms? 2 plus 1, 3 atoms, right? One molecule of carbon dioxide contains 3 atoms. So one molecule of carbon dioxide, it contains 3 atoms. 2 molecules of carbon dioxide multiplied by 2. 3 molecules multiplied by 3. 4 molecules multiplied by 4. How many molecules we have? 20 Na. So 20 Na molecules of carbon dioxide will contain 3 multiplied by 20 Na atoms. So in total, you are getting 60 Na atoms. So can I say one thing? Can I say 448 liters of carbon dioxide will contain in total 60 Na atoms? That's something which I was supposed to calculate. Is this super clear to everyone? Is this clear to everyone? Quickly, guys. The given substance was in molecular form. That's why moles multiplied by Avogadro's number gave me molecule. If the given substance was not in molecular form, if the given substance was in atomic form, then moles multiplied by Avogadro's number directly gives you. If the given substance is in ionic form, then moles multiplied by Avogadro's number, that directly gives you the number of. So you have to check first, what is the nature of the given substance? Is it molecular form? Is it atomic form? Is it ionic form? Whatever it is. I hope it's clear. So how that 3 atoms came, guys, it's clear, no? One molecule of carbon dioxide. Carbon dioxide has got 1 carbon atom, 2 oxygen atoms, so 2 plus 1, 3. Right? Okay, one more similar type of question. Calculate the number of atoms, electrons, protons, neutrons in 44.8 liters of carbon dioxide at ST. All these things are to be calculated, right? So before solving this particular question, I need to tell you some basic things, some basic stuff I need to tell you. For example, you have got the element X, whose atomic number is Z, whose mass number is M, right? There is no charge on this atom. For example, this atom X, it's electrically neutral. Whenever you'll be having the electrically neutral atom, right, you can say one atom of X contains how many protons? It contains Z protons. How many electrons? It contains Z electrons. How many neutrons? It's always going to be M minus Z. Mass number minus atomic number, neutron. What does it mean? For example, have a look. Let's say you are talking about sodium. Its atomic number is 11. Its mass number is 23. So this is the value of Z. This is the value of what? M. Perfect. So I can say one atom of sodium contains how many protons? It contains 11 protons. How many electrons? 11 electrons. How many neutrons? 23 minus 11 comes out to be 12. 12 neutrons. Correct? This complete basics which all of you must be knowing. Yeah. Similarly, dear students, for example, I'm writing something like this. Let's say I'm writing Mg di positive. Now charge is present on magnesium base. There's a di positive charge on magnesium. Magnesium, its atomic number you all must be knowing, that's 12. Its mass number you must be knowing, that's 24. Correct? Do remember, due to the presence of charge. Now magnesium has got di positive charge. Due to the presence of charge, nothing happens to the protons, nothing happens to them. Due to the presence of charge, nothing happens to protons, nothing happens to neutrons. Only thing that changes, what is that? Number of electrons. So I can say 1 Mg di positive ion. It contains 12 protons. How many neutrons? 24 minus 12. 12 neutrons. How many electrons? If there was no charge on magnesium, then 12 electrons. But there is di positive charge. That means 2 electrons have been taken out from magnesium. So 12 minus 2 comes out to be 10 electrons. So in 1 Mg di positive, you'll find 12 protons, 12 neutrons, and 10. As simple as that. Correct? Similarly, let's say I'm writing N tri-negative. Let's say I'm writing N tri-negative. Again, you have taken nitrogen and there's a negative charge on nitrogen. You have taken nitrogen, the charge is negative. Now, dear students, due to the negative charge, nothing happens to protons, nothing happens to, the neutrons. Only thing that changes is number of electrons. Yeah. So, its atomic number since is 7, its atomic mass is 14. I can say 1 N tri-negative contains 7 protons, 7 neutrons. How many electrons? If there was no charge on nitrogen, then 7 electrons. But there is tri-negative charge, so it has gained 3 electrons. So 7 plus 3. So in 1 and tri-negative, you'll find some 10 electrons. Correct? Simple, basic. Now, let's try to solve the question. The question is, calculate the number of atoms, then electrons, then protons, then neutrons in 44.8 liters of carbon dioxide. My dear students, have a look. First of all, check what is our given quantity. The given quantity is in terms of volume. What is my first step always? To convert the given quantity into number of moles. Do we know how to convert volume into moles? I'll be writing number of moles of carbon dioxide. Given volume of carbon dioxide in liters divided by 22.4 liters. Value comes out to be 2. First step is done. We have calculated the moles. Now second step. What is the second step? Check whether the given substance is in atomic form or molecular form. It's in molecular form. So second step will be moles multiplied by Avogadro's number. That gives you the number of molecules. Now calculate number of molecules. This is the second step. Number of molecules of carbon dioxide will be equal to 2 multiplied. So these many molecules of carbon dioxide, 2Na. Correct? Okay. Since we have calculated the molecules, now we are supposed to calculate the atoms. Now you tell me, in 1 molecule of carbon dioxide, how many atoms are there? 2 plus 1. 3 atoms, right? 1 molecule of carbon dioxide contains 3 atoms. So 2 molecules of carbon dioxide will contain, multiplied by 2. 3 molecules multiplied by 3. 4 molecules multiplied by 4. How many molecules we have? 2Na. So 2Na molecules of carbon dioxide will contain 3 multiplied by 2Na. The value comes out to be 6Na atoms. So in total, you will find these many total number of atoms present in 44.8 liters of carbon. Yeah? Perfect. Since atoms you have calculated, now it is the time to calculate electrons, right? Atoms you have calculated. Now it is the time to calculate electrons. If I talk about 1 molecule of carbon dioxide, this is 1 molecule of carbon dioxide, carbon and 2 oxygen. Atomic number 6. Here it's 12. This is 8, 16, 8, 16. In 1 atom of carbon, how many electrons are there? 6. How many electrons are there in 1 atom of oxygen? In 1 more. So 8, 8, 16, 6, 22. So in 1 molecule of carbon dioxide, there are 22 electrons. You will find 22 protons. And similarly, neutrons. 12 minus 6 is 6. Plus 16 minus 8 is 8. 16 minus 8 is 8. So again, 22 neutrons. So we just checked one thing, that in 1 molecule of carbon dioxide, there are 22 electrons, even 22 protons, even 22 neutrons. Can I write like this? Can I write 1 molecule of carbon dioxide? What does it contain? It contains 22 electrons, 22 protons, even 22 neutrons, right? If 1 molecule of carbon dioxide contains 22 electrons, so 2 molecules will contain, multiplied by 2. 3 molecules multiplied by 3. 4 molecules multiplied by 4. How many molecules we have? 2Na. So I can say 2Na molecules of carbon dioxide will contain 22 multiplied by 2Na. That means 44 Na electrons. That means 22 multiplied by 2Na. So comes out to be 44 Na protons. Similarly, 44 Na neutrons. Correct? So these were all the things which we were supposed to calculate. Atoms, electrons, protons, as well as in 44.8 liters of carbon dioxide at S. I hope this is super clear to everyone. Quickly, let me know in the chat with the thumbs ups. Everyone. Everyone, guys. Everyone. Everyone, quickly. Everyone, quickly in the chats. Yes, we shall be completing this chapter today. Whole chapter will be done. Now have a look. Look at this particular question. In this question, they are asking you, calculate the number of valence electrons in 4.2 grams of N trinegative. N trinegative. Since we have to calculate valence electron, correct? So I'll be following the diagram which I gave you. That diagram says convert the given quantity into number of. What is the given quantity? We are given with mass of N trinegative. The given quantity, that is the mass of N trinegative. We are supposed to convert the given quantity into moles. So let's calculate the moles of N trinegative, which is equal to given mass of N trinegative in grams divided by molar mass of N trinegative. Due to charge, nothing happens to the molar mass. Whatever is the molar mass of nitrogen, same is the molar mass of N trinegative. So due to the presence of charge, nothing happens. Molar mass of nitrogen, that is 24 grams per mole. Sorry, not 24, 14. 14 grams per mole. This value comes out to be what? 0.3. So we have converted the given quantity into number of. Now what used to be our second step? Moles into molecules. Moles into molecules, right? Look at it carefully. Is the given substance present in molecular form or ionic form? It's given in ionic form. Now, moles multiplied by Avogadro's number, that's not going to give me the molecules. That's going to give me the number of ions, right? So I can write number of N trinegative ions will be equal to 0.3. Right? So I got the ions. Now I'll check in one N trinegative ions how many valence electrons are there. Let's check that. In one N trinegative ion, how many total electrons are there? Since atomic number is 7, 7 plus 3 makes it 10. So there are total 10 electrons. Out of 10 electrons, there will be 2 electrons present in the first shell, 8 electrons present in the second shell. This second shell, which is the valence shell here, it's containing 8 electrons. So if I ask you, how many valence electrons are there in one N trinegative? So one N trinegative contains 8 valence electrons. Correct? One N trinegative contains 8 valence electrons. So if one N trinegative contains 8 valence, 2 N trinegative multiplied by 3 multiplied by 3. How many ions we have? 0.3 Na. So 0.3 Na N trinegative ions will contain 8 multiplied by 0.3 Na. The value comes out to be 2.4 Na valence electron. Right? Perfect. So these many valence electrons will be present in 4.2 grams of N trinegative. Is this clear to everyone? If it is super clear, do let me know once in the chats with a thumbs up. Everyone, quickly guys. Perfect. So here we have got again 3 more questions. Look at these questions here. These are again simple questions, basic questions. Calculate the number of atoms in 16 grams of helium. 16 grams of helium. You have to calculate atoms. So mass of helium is given, right? You have to calculate atoms. Helium is given in atomic form. So if we calculate moles of helium, then we multiply moles by the Avogadro's number. We'll be directly getting number of atoms. Correct? That's what we have been doing till now. So first thing, in order to solve the first question, I'll be calculating the number of moles of helium first, which is given mass of helium in grams divided by molar mass of helium. So I got the moles of helium, correct? Moles, since helium is in atomic form, now moles multiplied by Avogadro's number, that gives me what? That gives me the number of atoms of helium. Number of atoms of helium will be exactly equal to what? 4 Na. This clear? Simple? Correct? Now look at the second one. Calculate the number of atoms in 16U of helium. Here it's not grams, it's 16U of helium. It's not grams. So how you are going to solve it? Do you know what is the atomic weight of helium? 4 AMU. 4 AMU is the mass of one atom of helium. Correct? 4 AMU is the mass of one atom of helium. So 1 U will be the mass of 1 by 4 atoms of helium. And how many U are we given with? 16U. So 16U will be 1 by 4 multiplied by 16 atoms of helium, which comes out to be 4 atoms of helium. Correct? So as per the question, 16U of helium means 4 atoms of helium. Isn't it simple? That's all. We were supposed to check how many atoms are there in 16U of helium. So in 16U of helium, there are 4 atoms of helium. Nothing else. Again, simple. Look at the third one. Look at the third one. Again, you can see mass is not given in grams. If it was given in grams, then given mass divided by molar mass, that gives me the moles. Then moles multiplied by Avogadro's number, that gives me its molecules, right? That was the simple procedure if the mass was given in grams. But here again, the mass is not given in grams. It is given in AMU, might. What I'll be doing? HNO3, its molecular mass. That means mass of one molecule of HNO. 63. 63U is basically the mass of molecule of. Okay, 63U is the mass of one molecule of HNO. So dear students, what about 1U? Can I say 1U is equal to 1 by 63 molecules of HNO? 1U is equal to 1 upon 63 molecules of HNO3, right? How many U's are we given with? 126. So 126U has to be 1 by 63 multiplied by 120. Value comes 2 molecules. Two molecules of HNO. Is this clear? So that's something we were supposed to calculate. We were supposed to calculate how many molecules are present in 126U of HNO. So there are 2 molecules which are present in it. Clear? Is it super clear to everyone? Quickly. Quickly, guys. Break will be given at 8. Okay, not now. Perfect. Perfect, guys. Perfect. Now there is something like there is a particular type of questions which are again asked basically over here from the mole concept. Let's try to solve those questions. But before going into the details of the questions, let's have a look on the concept. Understand what I'm. My dear students, if I write 1 mole of H2SO4, 1 mole of H2SO4. Let me tell you, in 1 mole of H2SO4, what is present? In 1 mole of H2SO4, I can say there are 2 moles of H present. Where hydrogen I am taking in atomic form. 1 mole of H2SO4 contains 2 moles of H. Contains 1 mole of S as well. Contains 4 moles of O as well. Correct? Oxygen again I have taken in atomic. Guys, just a second. Somebody is here. Guess who is here? Guess who is here? Guess who is here? Till then I'm going to write something. Guess who is here? Guess who is here? Quickly. Cannot be Ambika ma'am, yaar.
Sir is saying, ma'am. See, somebody's name is Wassim. Yeah, none other than Capto, guys. See, Ambika ma'am is missing. So somebody should.
Missing, she's gone. She's dead.
Oops. Oops. That's it. Ambika ma'am is going to take Avenge. Hello, Sana. Hello, Harini. Hello, Sanjeev. What to do, man? Ambika ma'am is not there. No, somebody should come. No. So that's all. I'm doing Ambika ma'am's role over here. I'm going to teach biology also on her behalf. And everybody will rock it. Yeah. 18 out of how much is this? 360? 18 out of 180. No, but with my Tukka strategy, I think it will be more than 100. Yeah. Where is HSP sir? HSP sir is an.
Over. He's over. He's...
First time in Unacademy, Ashir. Welcome. Kya baat? Very good. Very good. Arey, my God, guys, you have good stamina, yeah? And where are those other 200-300 people who started with the session, and where are they gone? Started sleeping already. Call them. What is this? Wassim sir is here. He's going to teach you for more than 5-6 hours, and you are going to sleep. Call your friends. Yeah. Definitely. Then Wassim sir will teach physics. Ambika ma'am will teach maths. And our Venugopal sir will teach biology. Definitely. We'll have it.
HSP, sir?
HSP sir. Yes, he will be the student. Crazy, crazy. So, guys, I just came to say hello and just to cheer you up and continue watching this class till the end. Wassim sir will be taking a break after half an hour because he's going to come. Look at his dedication. He's going to come on the JE channel. So if you have your JE friends, let them know to come on the JE channel by Unacademy. Right? Okay. Hello, guys. See you. See you. All the best. All the best, Wassim sir.
Yeah, uska. Sir has got biryani for me, huh?
That is an awesome biryani, guys. Called Done Biryani. South would know about what is biryani. Please tell Wassim sir what is Done. Okay? Or he will leave the class.
Okay, let's have a look, guys. See now. Over here, I wrote one statement, 1 mole of H2SO4. It's very simple. In 1 mole of H2SO4, what you will find? You'll find 2 moles of hydrogen atom, 2 moles of H, 1 mole of S, 4 moles of O. Now, dear students, there is one thing which I would want you guys to know. Sometimes instead of moles, they'll ask you to calculate gram atom. Or they will ask you to calculate gram molecule. Gram atoms or gram molecules is nothing. These are moles basically. Gram atoms or gram molecules is nothing. It is just moles. When they ask you to calculate the gram atoms, that means they're asking you to calculate the moles. When they ask you to calculate the gram molecule, so indirectly it's like calculate the moles. Okay? Nowadays, students, have a look. 1 mole of H2SO4 contains 2 moles of hydrogen. Hydrogen here is in atomic form. Since hydrogen is in atomic form, so I can write 2. Instead of moles, I can write 2 gram atoms. I can write 2 gram atoms of hydrogen. Right? Perfect. I can write 1 gram atom of sulfur. Right? Here oxygen again is in atomic form. I can write 4. Instead of moles, I'll be writing gram atoms of oxygen. I hope it's super clear to you. Right? Now, my dear students, one more thing. Understand. No doubt, I wrote 1 mole of H2SO4 contains 2 moles of H. But if I want to write hydrogen in molecular form, should I be writing 1 mole of H2SO4 contains 1 mole of H2? Absolutely. 1 mole of H2SO4, it contains 1 mole of H2. Over here, hydrogen is in molecular form. So instead of moles, you can write 1 gram molecule. You can write 1 gram molecule of what? Of hydrogen. Talk about oxygen. Can I say 1 mole of H2SO4, it will contain 2 moles of H2? Yes, it contains 2 moles of, sorry, not H2O2. It contains 2 moles of O2. 2 moles of O2 means 4 moles of O. Here I have taken oxygen in molecular form. So I should be writing 2 gram molecules of oxygen. I hope all these things you can write. For example, let me give you one more example so that you can understand. I know it will be a little bit difficult for you guys to understand this, right? So let's take one more example. For example, I'm writing 1 mole of H2S2O8. First of all, I'm going to write all the statements considering the elements in atomic form. I'll write 1 mole of H2S contains 2 moles of H, 2 moles of S, 8 moles of O. I can write in a different format as well. Hydrogen here is in atomic form. So 2, instead of moles, I'll write gram atoms of hydrogen. I'll write gram atoms of hydrogen. Similarly, instead of 8 moles of O, oxygen here is in atomic form, I can write 8 gram atoms of oxygen. Now, these two statements, can you convert them into gram molecules? I want you guys to do that. Convert them into gram molecules. Can I say 1 mole H2SO4? It contains 1 mole of H2. Hydrogen here is in molecular form. So, instead of mole, you'll write gram molecule. So, 1 gram molecule of hydrogen. 1 gram molecule of hydrogen. 1 mole H2S2O8 contains 4 moles of O2. It contains 4 moles of O2. Oxygen here is in molecular form. So, I'm writing 4 gram molecules of oxygen. I hope all these statements are right. Now, dear students, if you know how to write these statements, then there's a particular set of questions which can be asked. How is that? This is the question. The question is, calculate the moles of O present in 196 grams of H2SO. Calculate the moles of O present in 196 grams of H2SO. Now understand. We have to calculate the moles of O which are present in 196 grams of H2SO4. Whenever you see this sort of a question, your first step always is going to be to convert the given quantity into number of. Your first step always will be to convert given quantity into number. Right? So first of all, let me calculate number of moles of H2, which will be equal. Given mass of H2SO4 in grams divided by molar mass of H2. The value comes out to be 2. So you have converted the given quantity into number of moles. Right? Well, my dear students, after doing the first step, what is the second step? Have a look what the second step is all about. Since we are given with H2SO4, right? So I'll write 1 mole of H2SO4. 1 mole of H2SO. Calculate the moles of O. Now tell me how many moles of O are present in 1 mole of H2SO4. I'll say 1 mole H2SO4. It contains 4 moles of O. Yes, 1 mole H2SO4 contains 4 moles of O. My dear students, now it's evident. If 1 mole H2SO4 contains 4 moles of O, how many moles of H2SO4 do we have? 2 moles. I'll say 2 moles of H2SO4 will contain 4 multiplied by 2. The value comes out to be 8 moles of O. That's something which we were supposed to calculate. Right? We got to know that we have got 196 grams of H2SO4. That means we have got 2 moles of H2SO4. In 1 mole H2SO4, there are 4 moles of O. So, 2 moles of H2SO4 will have 8 moles of O. 8 moles of O means 4 moles of O2. The question can be anything. They can ask you in terms of O. They can ask you in terms of O2. Right? They can ask you like this. 8 gram atoms of O. Or you can write 4 gram molecules of oxygen. I hope all these things are super clear to you. Yeah? Perfectly done? Perfectly done? One more thing which I would want you guys to remember. I'll give you one more example. Yeah, I'll give you one more example. But before that, have a look on the question. What we were supposed to calculate? We were supposed to calculate the moles of O. We were supposed to calculate the moles of O. That means we were supposed to calculate the data for O. that substance whose data is to be calculated, that always has to be on the right side of the statement. That's why this O is on the right side of it. If I was supposed to calculate the data for H2SO4, that means I was supposed to what? I was supposed to reverse the statement so that H2SO4 comes on the right. Okay? The one whose data is to be calculated, that has to be always on. Yeah? Let's try to solve one more question. Look at this question. Calculate the mass of H3PO4 that contains 0.25 moles of O. Calculate the mass of H3PO4 that contains 0.25 moles of O. What is the given quantity? The given quantity is 0.25 moles of O. The given quantity is already in terms of moles, so you need not to convert it like before. It's already in terms of moles, no need to convert it. Now, what is the statement which I'll be writing? Calculate the mass of H3PO4 that contains these many moles of O. So, can I say 1 mole of H3PO4 contains 4 moles of O? Absolutely. But the point is, do I need to calculate the data for O, or I have to calculate the data for H3PO4? I have to calculate the data for H3PO4, right? I have to calculate the data for H3PO4. The one whose data is to be calculated, that has to be on the right side. So, should I be reversing the statement? Absolutely. I'll be reversing the statement. So, can I say, after reversing the statement, can I say 4 moles of O are present in? 4 moles of O are present in 1 mole of H3PO4? Yes. 4 moles of O are present in 1 mole of H3PO4. Now, dear student, if 4 moles of O are present in 1 mole H3PO4, just use the unitary method. And I say 1 mole of O is present in 1 by 4 moles of H3PO4. Correct? Now, how many moles of O I am given with? I am given with 0.25. So, 0.25 moles of O are present in 1 by 4 multiplied by 0.25 multiplied by 0.25 moles of H3PO4. So, this is 1 by 4. This is also 1 by 4. The value comes out to be 1 by 16 moles of H3PO4. So, if I ask you, what did I calculate? If I ask you, what did I calculate? What should be your answer? You'll say, we calculated the moles of H3PO4. These are the moles of H3PO4, which contains 0.25 moles. These are the moles of H3PO4, which contains 0.25 moles of O. But my dear students, was I supposed to calculate the moles of H3PO4? No. I was supposed to calculate the mass of H3. I was supposed to calculate the mass of H3. So, dear student, mass of H3. Do you know how do you convert moles into mass? Moles of H3PO4 multiplied by what? Multiplied by molar mass of H3PO. Correct? So, mass of H3PO4 in grams will be equal moles 1 by 16, molar mass 98. The value comes out to be 6.125. So, what about the 6.125 grams? What is this? What is this exactly? This is basically the mass of H3PO4. This 6.125 grams. It is the mass of H3PO4. It is the mass of H3PO4 which contains 0.25 moles of O. That's something I was supposed to, right? This is the mass of H3PO4 that contains 0.25 moles of O. That's something I was supposed to calculate. What mass of H3PO4 contains 0.25 moles of O? I hope these sort of questions you will be easily solving from now. Yeah? Perfect. Perfect, guys. Quickly, guys, everyone. All right, perfect then. Okay. By the way, can you solve this question on your own? Can you solve this question on your own? Do you think you can solve this? Just read it carefully once and let me know. Can you solve this question? Quickly. This is your homework question. You're going to give it a try and let me know the answer of this particular question in the comment section of the video, okay? In the comment section of the video. Perfect. So till here, your basic mole concept is over. It's done, right? Your basic mole concept is done. Now, it is the time for the average molar mass of the gas. One more important topic, right? So let's get to know what the average molar mass of the gaseous mixture is exactly all about. Understand, properly understand. This is important. First of all, the average molar mass of a gaseous mixture, it is represented by MAV. It is represented by MAV. Now, what does it mean? My dear students, as per its definition, average molar mass of the gaseous mixture, it is defined as the mass of 1 mole of a gaseous mixture. The mass of 1 mole of a gaseous mixture. Now, what that exactly? See, guys, imagine that you have got a container over here, which is closed on all the sides. Imagine you have got a container, which is closed on all the sides. For example, in this container, you have got 2 chemically non-reacting gases. Let's say in this container, you have got 2 chemically non-reacting. One is N2 gas, one more is O3 gas. So there are 2 chemically non-reacting gases in the container. Can I say, first of all, in the container we have got a gaseous mixture? Yes, there is a gaseous mixture present in the container which contains 2 chemically non-reacting. My dear students, let's assume that in the container there are 2 moles of N2 and 2 moles of O3 as well. Let's assume that in this container there are 2 moles of N2 and 2 moles of O3 as well, right? So if I ask you how many total moles are there in the mixture, how many total moles are there in the gaseous mixture, you will say 2 plus 2, there are total 4 moles present in the gas. If I ask you what will be the mass of 2 moles of the N2 and what will be the mass of 2 moles of O3, how you are going to do that? See, molar mass of N2 is 28 grams, right? That means mass of 1 mole of N2 is 28 grams. But do I have 1 mole of N2 or 2 moles of N2? I have 2 moles of N2. Now, if the mass of 1 mole of N2 is 28 grams, that means the mass of 2 moles of N2 will be 6 grams, right? Similarly, what about the molar mass of O3? What about the molar mass of O3? That means 48, which is the mass of 1 mole of O3. But do I have 1 mole O3 or 2 moles? I have 2 moles of O3. If the mass of 1 mole of O3 is 48 grams, that means the mass of 2 moles of O3 will be 96 grams. So can I say in this particular container there are 56 grams of N? as well as 96 grams of ozone. Now, if I ask you one more thing, what about the mass of whole gaseous mixture? Mass of whole gaseous mixture will be mass of N2, 56 grams, plus mass of O3, 96. How much will be the value? It will be 152 grams. So I would say 152 grams is the mass of whole gaseous. Correct? Yes. So dear students, can I say something like this? 4 moles of a gaseous mixture, 4 moles of a gaseous mixture has got the mass of 152. The mass of 4 moles of gaseous mixture is 152 grams. What about the mass of 1 mole of a gaseous mixture? The mass of 1 mole of a gaseous mixture will be 152 divided by 4 grams. Can you let me know in the chats exactly what did we calculate? What is this term? What is this term? This is basically the mass of, this is the mass of 1 mole of a gas. As per the definition, the mass of 1 mole of a gaseous mixture. What do we call that? We call that as the average molar mass of the gas. So first of all, there were 2 chemically non-reacting gases in the container. That means there is a gaseous mixture in the container. Right? There is a gaseous mixture in the container. The mass of 1 mole of a gaseous mixture is something which we call as average molar mass. So right now, the scenario which I've taken over here, I got to know the mass of 1 mole of the gaseous mixture is 152 by 4 grams. So this is something which I'll be calling as average molar. Now, why I'm doing this? I just want to make the formula to calculate the average molar mass of. In the formula of average molar mass, there should be 2 terms, one in numerator, one in denominator. In the numerator, here you can see 152, which was basically the mass of mixture. So in the numerator, there has to be mass of the mixture in grams. And in the denominator, it is 4 here. And what was 4? 4 were basically the total moles present in the mixture. So this is one general formula by means of which you can easily calculate what? By means of which you can easily calculate the average molar mass of the gas. You do not have to do this procedure which I did over here. No need to do this. No need to do this. Just remember this result. Just remember this result. If you already knew this formula, then you were not supposed to do all this stuff. Mass of the mixture, that's 152 grams. Divided by moles present in the mixture, that's 4 in total. That gives you the average molar mass of the gas. That's all. So what is average molar mass of the gaseous mixture? First of all, in order to define the average molar mass of the gaseous mixture, what do we have? There should be 2 or more than 2 chemically non-reacting gases. The mixture should contain 2 or more than 2 chemically non-reacting. And whatever will be the mass of 1 mole of a gaseous mixture, that's something which you call as average molar. Nowadays, students, there are many results which we are going to generate over here to calculate the average molar mass of the gas. Right? Let's have a look what those results. Have a look, guys. Let's assume that we have got a container, and in this container, for example, there are 2 chemically non-reacting. That means in this container, what do we have? Again, I can say I have got a gaseous mixture present in this particular, which contains 2 chemically. Let's assume W1 represents the mass of gas 1 in the container, and W2 represents the mass of gas 2 in the container. W1 represents the mass of gas 1 in the container. W2 represents the mass of gas 2 in the container. Similarly, for example, N1 represents number of moles of gas 1 in the container, and N2 represents number of moles of gas 2 in the container. Similarly, M1 represents molar mass of gas 1 in the container, and M2 represents molar mass of gas 2 in the container. V1, let's assume V1 represents volume of gas 1 in the container, V2 represents volume of gas 2 in the container. Mole fraction of gas 1 represented by Chi1, mole fraction of gas 2 in the container represented. right? So dear students, dear students, if I ask you, what about the mass of gaseous mixture? What about the mass of gaseous mixture in grams? The gaseous mixture contains gas 1 and gas 2. Mass of gas 1 in the container, it's W1. Mass of gas 2 in the container, that's W2. So W1 plus W2, it gives me the mass of the total moles present in the mixture. N1 represents moles of gas 1 in the mixture. N2 represents moles of gas 2 in the mixture. N1 plus N2, it represents total moles present in the mixture. Now, few minutes back, I told you, whenever you'll be having 2 or more than 2 chemically non-reacting gases in the, that means you have got gaseous mixture in the container. And wherever you see the gaseous mixture in the container, what do we calculate? We calculate average molar mass for that gas. And how do you define the average molar mass of the gaseous mixture? That is basically the mass of 1 mole of a gas, right? So mass of 1 mole of a gaseous mixture is something which you call as average molar. And its formula is, 2 minutes back we discussed this formula, mass of the mixture in grams divided by total moles present in the mixture. This is one result. You can convert it in different result. The mass of the mixture is W1 plus W2. Total moles present in the mixture is N1 plus N2. Correct? Similarly, if I ask you how do we calculate number of moles? Given mass of the substance, divided by molar mass of the substance. That's how you calculate number of moles. If I write 1, 1 and 1. So, can you calculate W1 from here? And I say W1 is nothing, it's M1, N1. M1, N1. So, instead of W1, I can write M1, N1 plus W2 is going to be M2, N2. Divided by what? Divided by N1 plus N2. This is one more formula by means of which you can calculate the average molar mass. Okay. Similarly, dear students, in order to calculate average molar mass of the gaseous, we can use one more. This is the denominator N1 plus N2. It is the denominator of this term as well as denominator of this term. So I'll be writing M1 N1 divided by N1 plus N2 plus M2 N2 divided by N1 plus N2. Does not make a difference, right? This is the denominator of the first term as well as second. So you can convert it in a different format. You can write M1 as such, M1 as such. N1 divided by N1 plus N2. Number of moles of gas 1 in the container divided by total moles present in the container. Should I be calling that as mole fraction of gas 1? Plus M2, N2 divided by N1 plus N2. Should I be calling that as mole fraction of gas 2? Right? Isn't it simple again? Right, guys? Basic, simple. Now, similarly, you can write one more thing. Whenever I'll be using the term as mole percentage, what is mole percentage? Mole percentage is nothing. It is mole fraction multiplied by 100. Mole percentage is nothing. It is mole fraction multiplied by 100. That means mole fraction is nothing. It is mole percentage divided by 100. Correct? So here, I can modify this result as well. Average molar mass of the mixture is going to be M1. Instead of mole fraction of gas 1, you will be writing mole percentage of gas 1 divided by 100 plus M2 you are writing as such. Mole fraction of gas 2 you are going to write mole percentage of gas 2 divided by 100. So my dear students, how many results did we get till now in order to calculate the average molar mass of the gaseous mixture? This is the first result. This is the second result to calculate the average molar mass of the mixture. This is the third result to calculate the average molar mass of the mixture. This is the fourth result to calculate the molar mass of the mixture. And this is the fifth result by means of which you can calculate average molar mass of the right? Perfect. Similarly, dear students, there can be one more result as well. There can be one more result as well. And what that result is going to be. Have a look. For example, if the gaseous mixture is present at constant pressure and temperature. That means the gaseous mixture which I have taken in the container, let's say its pressure and temperature, that's fixed. Let's say pressure and temperature of the mixture does not change at all. That's how I say that the mixture is present at constant pressure and temperature. I do not have to let the pressure and temperature of the gas to change. I do not have to let the pressure and temperature of the mixture to change. Then only I can say the gaseous mixture is present at constant. My dear students, you know, as per ideal gas equation, PV is equal to nRT. If pressure and temperature of the mixture is kept constant, R is already constant, I can say volume is directly proportional to moles, right? So wherever in this particular equation do you see moles, replace the moles by, right? And how you are going to replace it by volume? Now you are going to write the result. MAV is equal to M1. Instead of N1, you are writing V1 plus M2. Instead of N2, you are writing V2 divided by V1 plus V. But if I ask you whether this particular result it's valid under all conditions or not, this particular result to calculate the average molar mass of the mixture, it's not valid under all conditions. It's valid only when the pressure and temperature of the mixture is kept constant. Right? Is this clear to everyone? Quickly. Is this clear to everyone, people? Quickly. So we have got basically different results by means of which you can calculate average molar mass of a gaseous. So from now onwards, if you see two or more than two chemically non-reacting gases present in the container, one thing should strike your mind, that you should calculate its average molar mass of the mixture. You should calculate the average molar mass of the gaseous mixture. Right? It hardly matters whether the question is from this chapter or some other chapter. Wherever you see two or more than two chemically non-reacting gases in the container, your first step always should be to calculate the average molar mass of the gas. And a lot of results we have to calculate the average molar mass of the gaseous mixture. You can use any one and get the average. Basically, mass of 1 mole of a gas. Right? I hope it's clear. So let's try to solve a few questions so that you can understand. Look at this question, guys. Calculate the average molar mass of the gaseous mixture containing 4.4 grams of gas A, 6.4 grams of gas B, and 4.8 grams of gas. So as per this particular question, it is the simplest of all. There are 3 gases present in the container. Gas 1, gas 2, gas 3. Or you can write gas A, gas B, gas. The choice for you. So as per the question is concerned, how many grams of gas A are there? As per the question, we have got 4.4 grams of gas A in the container. Similarly, how many grams of gas B in the container? 6.4 grams of gas B in the container. Similarly, 4.8 grams of gas. 4.8 grams of gas C. Right? What about the molar mass of gas A? Molar mass of gas A, as per the question, that's 44 grams per mole. Molar mass of gas B, that's 64 grams per mole. Molar mass of gas C, how much is that? Molar mass of gas C, that's 48 grams per. 48 grams per. What do I have to calculate? As per the question, we have to calculate the average molar mass of the gaseous mixture. Since we are given with a gaseous mixture, we have to calculate its average. Now, dear students, we have got a lot of formulas by means of which we can calculate the average molar mass. Correct? There are a lot of formulas. But which formula do I use right now to calculate the average molar mass of the mixture? I can use the result W1 plus W2. There is third gas, so W3 divided by N1 plus N2 plus N3. Correct? Now, as per the question, W1, W2, W3 are given to me. Right? W1, W2, W3 are given to me. W1 is 4.4, W2 is 6.4, and W3 is 4.8. Divided by, what is N1? N1 stands for number of moles of gas 1 in the container, which is basically mass of gas 1 divided by molar mass of gas 1 plus N2, mass of gas 2, molar mass of gas 2, N3, mass of gas 3 divided by molar mass of gas 3, right? So you can write MAV, average molar mass of the mix. 4.4 plus 6.4, that's 10.8. 10.8 plus 4 means 14.8. 14.8 plus 8 is 15.6, right? 15.6 grams divided by W1 by M1. W1 value we know, M1 value we know. 4.4 divided by 44, that's 0.1. This term will be again 0.1, this term again 0.1. So it's going to be 0.3, right? So this value will come out to be 156 divided by 3. So the value will be 3 5s are 15, 3 2s are 6. So 52 is the value of average molar mass of the mixture, right? Since we are calculating molar mass basically, and its units are supposed to be in grams per. So I can say mass of 1 mole of a gaseous mixture right here will be simply how much? It will be 52. Is this clear to everyone? Quickly in the chats once. Yes, Chandru, you can get the previous class. Quickly let me know in the chats if this is clear to everyone. Quickly, guys. Perfect. Let's try to solve one more question. Let me see if you can solve one more question or not. One simple question I'm giving you. The question is, again you have got a gaseous mixture in the container. Since there are two gases, one is carbon dioxide and one more is O2. Let me call this carbon dioxide as gas 1. Let me call O2 as gas 2. There are two gases in the container, carbon dioxide and O2. First of all, if I ask you, what about the molar mass of carbon dioxide? You will say it's 44 grams per mole. Similarly, what about the molar mass of O2? It is 32 grams per mole. Right? As per the question, the mole percentage of carbon dioxide, that's given to me as 60. Similarly, mole percentage of O2 is equal to 40. Mole percentage of O2 is equal to. What do I need to calculate? I need to calculate the average molar mass of the gaseous mixture. My dear students, few minutes back only, I gave you one result in terms of mole percent, right? In terms of mole percent. What is that? That's going to be M1 multiplied mole percentage of gas 1 divided by 100 plus M2 mole percentage of gas 2 divided by 100. Correct? Now put all the results, all the values in the result. M1 value, as per the question, is 44. Mole percentage of gas 1, that's 60 divided by 100 plus M2 value, that's 32. Mole percentage of gas 2, how much is that? That's 40 divided by 100, right? Give it a try. Final value you will get as 39. So this 39.2, what is it? It is the average molar mass of the mixture. Average molar mass of the mixture. And you know, the units of molar mass, nothing, it's just grams per. That means mass of 1 mole of a gaseous mixture right now is 39. I hope this is super clear. Yeah? Perfect. Perfect, guys. Simple and basic again. All right, one more question. The question is, at 27 degrees centigrade and 1 atm, a given mixture of O2 and SO2 contains gases in 2:1 volume. Calculate the number of moles present in 20 grams of the mixture. What does it mean? Have a look what it means. As far as this particular question is concerned, we have got two gases in the container. One is O2 and one more is. These are the two gases in the container. Right? Well, can I say I've got a mixture of gas in the container? Absolutely. And this mixture of gas, it's kept at constant pressure and temperature. The mixture of gas is kept at constant pressure and temperature. So one thing that is striking my mind right now, that since I've got a mixture of gas, the mixture of gas is kept at constant pressure and temperature. And whenever there is a mixture of gas kept at constant pressure and temperature, if by chance you need to calculate its average molar mass, how do you do that? Which formula do you use? You will be using the volume wali formula to calculate, right? So by chance, if I need to calculate the average molar mass of the mixture, I will do that with the help of volume wala, right? Because there's only one result which is used to calculate MAV at constant pressure and temperature, volume. Yes? What do I need to calculate actually? I need to calculate the number of moles present in 20 grams of the mixture, right? So, as per the question, mass of the gaseous mixture is given to me as 20 grams. This is the mass of whole mixture. What do I need to calculate? I need to calculate total moles present in the mixture. Correct? Total moles present. That's something I need to. Simple, guys. I need to calculate total moles present in the mixture. I say it's going to be mass of the mixture divided by molar mass of the mixture. And molar mass of the mixture is something which you call as average molar mass. As simple as given mass of the mixture divided by what? Given mass of the mixture divided by average molar mass of the mixture. That gives me the total moles present in the mixture. Mass of the mixture is given to me as 20 grams divided by average molar mass of the mixture is not given to me, so I will have to calculate. Let's call this as gas 1, O2. Let's call the SO2 as gas 2. Right? Molar mass of O2, you know, it's 32 grams per mole. Molar mass of SO2, that's 64 grams per mole. These two gases, they are present in the volume ratio of 2:1. They are present in the volume ratio of 2:1. My dear students, since they are present in the volume ratio of 2:1, so what is going to be the volume of O2 here? What is the volume of gas 1 here? It has to be 2x and volume of gas 2 has to be x. Simple multiplying both sides by x. That's all. V1, V2 we got. Since we got V1, V2, M1, M2 we already know. So can I calculate M average over here? It's going to be M1, V1 plus M2, V2 divided by what? Divided by V1 plus V2. And dear students, M1 value you know, V1 value you know, M2, V2, everything you know. Put all the values into this expression. You'll be getting the final result as 128 divided by 3 grams per. This is the average molar mass of the gaseous mixture which we got. Was I supposed to calculate the average molar mass of the gaseous mixture? Yes, I was supposed to calculate average molar mass of the gaseous. That's why I calculated. Now put it here. It's going to be 20 divided by 128 by 3. The value comes out to be 60 divided by 120. So what the 60 by 120 is all about? What is it? What the 60 divided by 128 is all about? These are basically the total number of moles. These are the total number of moles present in 20 grams of this gas, which I was supposed. Quickly, let me know in the chats if everyone got the concept of solving this particular question. Quickly. Can you all solve this question from now on? Quickly, guys, everyone. Everyone. Is it clear? I think you all are sleeping. Right? Are you feeling sleepy? What about you guys? Is it clear to you? Yeah? Chandru, you have to use the code as AVENGER, AVENGER. Perfectly done? All right. So let's move on to one more question then, which can be asked. Let's have a look on. The question is 600 ml mixture of O2 and O3 at STP weighs 1 gram. Calculate the volume of ozone in the mix. It's a nice question. Let's see how this sort of a question is. As far as the question is concerned, Imagine that this is a container, and in this container we have got two gases. One is your O2 gas, one more is ozone. These are the two gases present in as per the. Yeah. Now, my dear students, the gaseous mixture, it is present at STP. The gaseous mixture is present at. What does that mean? That means the pressure and temperature of the mixture is kept constant. The pressure and temperature of the mixture. So, one thing is striking my mind. What is that? If I by chance need to calculate the average molar mass of the mixture, which formula do I need to use? Using the volume alone. Yeah, I'll be using the volume alone. Correct? And how exactly? Have a look. Let's read the question. 600 ml mixture of O2 and O3. So, as per the question, the volume of the whole gaseous mixture is 600 ml. Volume of the whole gaseous mixture is 600 ml. And 600 ml mixture of O2 and O3. It weighs how much? It weighs 1 gram. So 1 gram is the mass of whole gaseous mixture, and 600 ml, it is the mass, it is the volume of whole gaseous mixture. Let's do one thing. Let's assume in 600 ml of gaseous mixture, let's assume volume of O2 is, for example, xml. Therefore, volume of O3 over here is going to be 600 minus x. Do you agree with this? Right? Assuming that volume of O2 in the mixture is xml. Therefore, volume of O3 in the mixture has to be 600. 600 minus x. Yeah? If I ask you, what about the molar mass of O2, which I'm representing by M1? 32 grams per mole. Molar mass of O3, which I'm representing with M2, 48 grams. Correct? As simple as that. Now, my dear students, we have got two gases present in the mixture, which is present at STP. So, pressure and temperature of the mixture is constant. The mass of the gaseous mixture is 1 gram. The volume of the gaseous mixture is 600 grams. I have assumed out of 600 ml of the mixture, let's assume x ml is the volume of O2 in the container. Therefore, 600 minus x, it is going to be of O3. Yeah? Cool with this? Now we can do one thing. If I ask you, how many total moles are there in the gaseous mixture? This is a simple question which I. How many total moles are there in the gaseous mixture? Since mass of the gaseous mixture is 1 gram, total moles present in the mixture is going to be mass of the mixture in grams divided by molar mass of the gaseous mixture, which is what you call as MAV. So it's 1 divided by MAV. Right? Is there any other way to calculate the total moles present in the gaseous mixture? If I ask you, is there any other way to calculate total moles present in the gaseous mixture? Since volume of the gaseous mixture is 600 ml and the gaseous mixture is present at STP, so it's going to be given volume of the mixture in ml divided by what? Divided by 22400 ml. So from here, I got 6 divided by 224. I got the value 6 upon. Yeah. Now if I ask you, what is this 1 upon MAV? It gives me the total moles present in the mixture. 6 upon 224, it again gives me the total moles present in the mixture. It is just, I've used two different results, but eventually you are getting the same. Yeah. So from here, can I say, from these two equations, can I say 1 upon MAV has to be equal 6 upon 224. Correct? So from this equation, after cross multiplying, I'll say MAV is equal to 224 divided by 6, since you have calculated the average molar mass of the mixture. So it's grams per mole. Right? Grams per mole. Perfect. 224 by 6 grams per mole. That is the average molar mass of the mixture. But as per the question, am I supposed to calculate the average molar mass of the mixture? No. What do I need to calculate? I need to calculate the volume of ozone present in the mixture. I need to calculate the volume of ozone present in the mixture. My dear students, as per the question, MAV we got to know as 224 divided by 6 grams per. What is MAV? It's average molar mass of the gaseous mixture. Instead of MAV, can I write M1V1 plus M2V2 divided by V1 plus V2, which is equal to 2 to 4 divided by 6, right? Now the point is, what is the value of M1? M1 value is 32. What is the value of V1? That's X. M2 value, 48. V2 value, that's 600 minus 6, divided by V1 plus V2. V1 plus V2 comes out to be 600. And this is equal to 2 to 4 divided by 6. It is a matter of just cross multiplication and get the value of X from here. And the value of X, after solving, you'll get it as 200 ml. X you got. That means X was the volume of what? X was the volume of O2. Therefore, volume of O3 in the mixture will be equal to 600 minus 6. So 600 minus 200 comes out to be 400. That is the volume. Right? Perfect. Or did I do the reverse? I think this value will come out to be 400 and this is 200. One of the two. Okay? One of the two. Perfect. Either this value will be 400 or this value will be 400. You can check that out after solving it properly. Okay? So is it clear till here? Quickly. Quickly, guys, everyone. Is it super clear to everyone? Yes, you can join from this topic. No issues at all. Perfectly done. All right. Let's move on then. Let's move on, guys. Just a second. Okay. Let's move on to one more important topic of this chapter, stoichiometry. Okay, so what is the stoichiometry example? Let's have a look. It's again one simple topic, but let's try to understand this. So in order to make you understand the stoichiometry, what I'm going to do, I'm going to take a general reaction. And the reaction I'm taking in N2 plus H2, it gives NH. This is the reaction which I've taken. This is the reaction which I've taken. N2 plus H2 gives. First of all, is this reaction balanced or unbalanced? The reaction is unbalanced. Reaction is unbalanced. Whenever you want to use stoichiometry in the reaction, the first step always is to balance them. So let's try to balance the reaction. This has to be 3 times. This has to be 2 times. This has to be 1. So first of all, the reaction is balanced. After balancing a reaction in stoichiometry, this 1, 3 and 2. This 1, this 3 and 2. What do we call this 1, 3 and 2 as? This 1, 3 and 2, you will be calling it stoichiometric coefficient. You'll be calling this 1, 3 and 2 as the stoichiometric. And my dear students, these stoichiometric coefficients, let me tell you, they are treated as moles. They are considered as moles. So first of all, whenever we need to use stoichiometry basically in the reaction, we are supposed to balance the reaction. After balancing the reaction, you can write different types of statements. For example, one type of statement you can write. Since I told you, you can treat these stoichiometric coefficients as moles. You can say from the stoichiometry of the reaction, from the stoichiometric coefficients over here, you can say 1 mole of N2 completely reacts with 3 moles of H2 to produce 2 moles of NH. You can say something like 1 mole of N2 completely reacts with 3 moles of H2 to produce what? To produce 2 moles of NH. This is the data which you are getting only if you know the stoichiometric coefficients. And this type of statement you only wrote in terms of moles. That means I'm using mole method over here. Correct? So guys, it's evident now. Since you got to know 1 mole of N2 reacts with 3 moles of H2. So what about 2 moles of N2? Can I say 2 moles of N2 will react with 6 moles of H2, will form 4 moles of NH3? Can I say 3 moles of N2 will react with 9 moles of H2, will form 6 moles of NH3? Correct? All these things you can say. All these things you can say. This was one statement which was clearly in terms of moles. Let's have a look on one more statement. If I ask you, what about the mass of 1 mole of N2? What does that mean? Mass of 1 mole of N2 means molar mass of N2. The molar mass of N2 is nothing, 28 grams. It's 28 grams. So instead of 1 mole of N2, you can write 28 grams of N2. Now, if I ask you, what is the molar mass of H2? You'll say 2 grams. 2 grams is the mass of 1 mole of H2. But here we have 3 moles. So mass of 3 moles of H2 will be 6 grams. Molar mass of NH3, 17 grams. That means the mass of 1 mole of NH3, 17 grams. And over here we have got 2 moles. The mass of 2 moles of NH3 will be 34 grams. Dear students, we got to know. Dear students, we got to know. 28 grams of N2 completely reacts with 6 grams of H2 and produces 34 grams of NH3. And produces 34 grams of NH3, right? Right, people? Perfect. So have a look exactly. This particular statement which I wrote over here, I wrote in terms of mass. So I'm calling this method in stoichiometry as mass. Now I can write one more statement. I can treat these stoichiometry coefficients directly as moles. I can treat these stoichiometry coefficients directly as volume. How exactly? I can say from the stoichiometry coefficients, 1 volume of N2 completely reacts with 3 volume of H2 and produces 2 volume of NH3. This volume term you can use in terms of liters, in terms of ml or whatever. What does that mean? That means I can say 1 liter of N2 completely reacts with 3 liters of H2 and produces 2 liters of NH3. And do these two statements are used in terms of volume. That means which method I'm using in stoichiometry here? I'm using the volume. Right? Well, it's not mandatory that you will be taking this volume in liters. You can take it in ml as well. You can say 1 ml of N2 reacts with 3 ml of H2 and produces 2 ml of NH3. All these statements you should be able to write, right? You should be able to write all these statements either in terms of mass or in terms of volume or in terms of moles. You should be able to write all these statements for all the reactions. Yeah? Perfect? Perfect, guys? So in order to write all these statements, you should first of all balance the reaction. That's important. That's important, like how to balance. I hope this is clear. I hope this is clear. So one by one, we'll check how to use the mole method, how to use the mass method, and how to use the volume method. One by one, we are going to check these methods. One by one, we are going to check these methods. But one thing which I would want you guys to remember, whenever we will be using mole method in the questions, at that point of time, whenever we try to use the mole method in the questions, first step always will be to balance the reaction. Second statement will be always to convert the given quantity. This will be always our second step in the mole method. In the mole method, when we use the mole method, my first step will be to balance the reaction. Second step will be convert the given quantity into number of moles. And third step, write the similar type of a statement. This will be the third step. Write the similar type of this in terms of mole. Okay? And dear students, whenever you will see me using mass method in stoichiometry, if I'm using the mass method, that means after balancing the reaction, I'm supposed to convert the given quantity into mass. Well, after converting the given quantity into mass, then I'm supposed to write this kind of a statement. I'm supposed to write this kind of a statement in terms of same goes for volume. So one by one, we'll check how exactly the different methods in stoichiometry are used in the question. But before doing the question, there are some reactions which I would want you guys to, right? some reactions which are frequently used in stoichiometry. Some reactions which are frequently used. For example, the first reaction, KClO3, upon heating, when you heat it up, it gives KCl solid. With this, you get O2 gas. This is one very common reaction which is used in stoichiometry. Okay, number one. Number two, calcium carbonate solid upon heating. It produces calcium oxide. With calcium oxide, you'll be getting carbon dioxide. This is one more important reaction. Third reaction, NaHCO3, sodium bicarbonate upon heating. It gives sodium carbonate, Na2CO3 plus carbon dioxide plus water. This is one more important reaction which is frequently used. Na2CO3, when you heat it up, sodium carbonate, when you heat it up, nothing happens. Nothing happens. No reaction takes place here. Similarly, what all other reactions we have? BaCl2 plus Na3PO4. It gives Ba3PO4 whole twice plus NaCl. One more important reaction which we frequently use here. Similarly, if you take the hydrocarbon, CXHY, hydrocarbon, if you do its combustion, it will lead to the formation of carbon dioxide. With this carbon dioxide, we'll be writing water as well. I'm writing the reaction in the balanced format. X times, this is Y by 2 times, and the stoichiometric coefficient of O2 will be X plus Y. For example, if you take CH4 here, the value of X is 1, the value of Y is 4, plus X plus Y by 4. So 1 plus 4 by 4. 1 plus 1, that comes out to be 2. 2 times O2. What does it give? X times carbon dioxide. What is X value? 1. So 1 times carbon dioxide. Plus Y by 2. 4 by 2. 4 by 2 is 2. 2 times water. Okay? So remember this equation in the generalized form, right? Then you can derive all the other equations. Okay? Right, people? Right? Now, let's exactly get to know how to solve different questions in stoichiometry. The first question, which is on your screen. Let's have a look. The question is very simple, guys. Calculate the mass of oxygen gas produced upon heating 12.25 grams of KCl. So first of all, whatever questions I'll be showing you now, I'll be solving all the questions with the help of which method? I'll be solving all the questions with the help of mole method. I'll be solving all the questions with the help of mole. Okay? So as per the question is concerned, what we are doing, we are heating. What we are heating? We are heating up KCl. And you know when KClO3 solid is heated up, it gets converted into KCl, and with KCl, you write O2 as well. This is the reaction which happens, correct? Now, as per the question, how many grams of KCl you are heating up? We are heating up 12.25 grams of KCl. Okay? So, this is my given quantity here. This is my given quantity. Which method am I using? I'm using the mole method. What is the first step in the mole method? Convert the given quantity into number of moles. Convert the given quantity into number of moles. We are given with the mass of KClO3. So, I'll be converting the given mass of KClO3 into moles of KCl. So, my first step will be to calculate the given quantity into moles. Mass of KClO3 into moles of KCl is equal to given mass of KClO3 in grams divided by molar mass of KClO3. The value comes out to be 0. Now, it's completely yours. So you want to say that we are going to heat up 12.25 grams of KClO3, or you can say we are going to heat up 0.1 moles of KClO3. The choice is all yours. The choice is all yours. Whether you want to say that we are going to heat up 12.25 grams of KClO3, or you want to say that we are going to heat up 0.1 moles of KClO3. That means the same, one and the same, right? So what to do here now? First thing, we are using the mole method. In mole method, we are supposed to balance the reaction. So this has to be 2 times, this has to be 2, and this has to be reaction is. right? The reaction is back. We have already converted the given quantity into mole. Now, since we have got one reactant and two products, now what you'll be doing, you'll be writing one statement. See, KClO3 is the one whose data is given and oxygen is the one whose data is to be calculated. Correct? KClO3's data is given. O2 data is to be calculated. So you just need to relate these two things instead. Okay? So you can say from the mole method, you can say 2 moles of KClO3 upon heating gives 3 moles of O2. Right? Stoichiometry is telling us that 2 moles of KClO3 upon heating gives 3 moles of O2. Now we use the unitary method. What about 1 mole KClO3? 1 mole KClO3 upon heating gives 3 by 2 moles of O2. Correct? Gives 3 by 2 moles of O2. But as per the question, are we heating 1 mole of KClO3? No. We are going to heat 0.1 moles of KClO3. So 0.1 moles of KClO3 upon heating, it gives 3 by 2 multiplied by 0.1. The value comes out to be 0.15 moles of O2. So what this term is all about? Can I say basically these are the moles of O2 which are being produced. These are the moles of O2 which are being produced upon heating 0.1 moles of K. Upon heating 12.25 grams of K. But as per the question, where we suppose calculate the moles of O2 produced or mass of O2 produced. I was supposed to calculate the mass of O2 produced. Mass of O2 gas produced will be equal to moles of O2 produced multiplied by molar mass of O2. Moles of O2 produced is 0.15 and this is 32. The value comes out to be 4. What does this 4.8 grams mean? What does it mean? It means 4.8 grams of O2 are being produced upon heating 12.25 grams of KClO3. One statement which I told you long back, the one whose data is to be calculated, has to be on the right side of it. The one whose data has to be calculated, it has to be on the right side of it. Okay? Perfect. Now, my dear students, you can just reverse the same question. I'm using mole method right now. Okay? You can reverse the question as well. And how exactly you can reverse the question? Let me show it to you. I mean, the question can be like this. Calculate the mass of KClO3 required to produce 4.8 grams of O2 during its decomposition. The question can be like this as well. Correct? Can be like this. So, since we know KClO3 solid upon heating, what does it give? It gives KCl, and with KCl you write O2. So, since we are solving all the questions with the help of mole method. So, this is 2 times, this is 2 times, this is 3 times, right? Now, as per this question is concerned, calculate the mass of KClO3. We have to calculate the mass of KClO3, which is required to produce 4.8 grams of O2. This is my given quantity. It's my given quantity. Since I'm using the mole method, so what am I supposed to do? I'm supposed to convert the given quantity into number of moles. This is my given quantity. Convert the given quantity into number of moles. Convert the given mass of O2 into moles of O2. Moles of O2 is equal to given mass of O2 divided by molar mass of O2. The value comes out to be 0.15. So as per the question, we have to produce 4.8 grams of O2. As per the question, we have to produce 0.15 moles of O2. Correct? Correct, people? Now understand one important thing. As per the question, we are supposed to calculate the mass of KClO3. We are supposed to calculate what? Mass of KClO3. So data for KClO3 is to be calculated and data for O2 is given. Data for O2 is given. And data for KClO3 is to be calculated. So we are just going to relate these. We have got nothing to do with KC. We have got nothing to do with KC, right? Okay. Right? Now understand one important. How would I write this statement? I can write the statement like this. 2 moles of KClO3 from the stoichiometry, 2 moles of KClO3 upon heating, it produces 3 moles of O2. Correct? I told you one thing few minutes back. The one whose data is to be calculated has to be on the right side. Now, whose data I need to calculate basically? I need to calculate the data for KC. That means KClO3 has to be on the right. What I'll be reversing the equation. I'll be reversing the equation. And how you are going to reverse the equation? You'll say 3 moles of O2 are produced. 3 moles of O2 are produced from 2 moles of KClO. 3 moles of O2 are produced from 2 moles of KClO. So that means 1 mole O2 is produced from 2 by 3 moles of KClO. Okay. But was I supposed to produce only 1 mole of O2? No. I was supposed to produce 0.15 mole. As per the question, 0.15 moles of O2 are produced from 2 by 3 multiplied by 0.15. The value will be 0.1 moles of KClO. Okay. So what did I calculate till now? What did I calculate? I basically calculated the moles of KClO. These are the most moles of KClO3 which are enough to produce 0.15 moles of O2. These are the moles of KClO3 which are enough to produce 4.8 grams of O2. But was I supposed to calculate moles of KClO3? No. I was supposed to calculate mass of KClO3 will be equal to moles of KClO3 multiplied by molar mass of K. Both the things here. This term is 0.1. Molar mass of KClO3, that's 122.5 grams per. Value finally comes out 12. So this is basically the mass of KClO3 which is required. This is the mass of KClO3 which is required to produce 4.8 grams of O2, right? Is it clear? Is it clear to everyone quickly? Quickly, guys. Quickly. Let's try to solve one more question. One more simple question. I'm solving all the questions right now from the stoichiometry, okay? From the stoichiometry with the help of mole method. I did not use the mass method. I'm just showing you the mole method. All right. Look at this question carefully. Calculate the volume of carbon dioxide. Calculate the volume of carbon dioxide produced at STP by complete combustion of 570 grams of octane. So as per the question, we are doing the combustion of octane, right? What is the formula for octane? It's C8H18. Octane, you are doing its combustion. And during the combustion of the hydrocarbon, we always get carbon dioxide with water, right? We always get carbon dioxide with water. Now, since we are using the stoichiometry, and which method in stoichiometry are we using? We are going to use the mole method. In the mole method, what do? We first of all try to balance the reaction. This is 8, so this has to be 8 times. 18 has to be 9 times. This will be x plus y by 4, which makes it 25 by 2. Correct? The reaction is done. It's balanced. Number 1. Number 2, convert the given quantity into number of moles. This is my given quantity. I'm given with mass of octane. I am given with the mass of octane. So I'm going to convert the mass of octane into moles of octane. So moles of octane is equal. Given mass of octane in grams divided by molar mass of octane is 114 grams. The value comes out. Now it's completely your choice. Whether you want to say that we are doing the combustion of 570 grams of octane, or you can say we are doing the combustion of 5 moles of octane. The choice is all. Whatever you want to say. Now, my dear students, the one whose data is given, that's octane. and the one whose data is to be calculated. And the one whose data is to be calculated. We just need to relate these two. That's all. Stoichiometry coefficient here is 1. Error is 8. So can I say from the stoichiometry of the reaction, I got to know 1 mole of octane upon combustion produces 8 moles of carbon dioxide. Right? 1 mole of octane upon combustion produces 8 moles of carbon dioxide. But as per the question, do we have to do the combustion of 1 mole of octane, or we have to do the combustion of 5 moles of octane? So I can say 5 moles of octane upon combustion produces 8 multiplied by 5. That means 40 moles of carbon dioxide. So you got to know in total 40 moles of carbon dioxide are being produced. But am I supposed to calculate the moles of carbon dioxide produced or the volume of carbon dioxide produced? We need to calculate the volume of carbon dioxide produced at STP, which will be equal to moles of carbon dioxide produced multiplied by 22.4 liters. This is 40 multiplied by 22.4. The value comes out to be 896 liters. So this is basically the volume of carbon dioxide which is being produced when we do the combustion of 570 grams of octane, or you can say when we do the combustion of 40 moles of octane. Yeah? Right, people? Is it clear to everyone? Is it clear to everyone? One more simple question we have. We are already given with the reaction. The reaction is 3 times NO2 gas plus H2O liquid. It gives 2 times HNO3 plus NO. How many grams of NO2 are required to produce 25.2 grams of HNO3? Since we are using the mole method, the first step is to balance the reaction. The reaction is already balanced. Second step, convert the given quantity into moles. This is my given quantity here. So convert it in terms of number of moles. So convert the mass of HNO3 into moles of HNO3. So it's going to be equal to given mass of HNO3 in grams divided by molar mass of HNO3. Can you let me know in the chats what is the exact value which you get after solving this? Can you let me know in the chats quickly? What is the exact value which you get after solving this quickly? Everyone. What is the exact value you get after solving this? 0.4, yeah? 0.4. So what did we do? We converted given mass of HNO3 into moles of HNO3. Now, as per the question, how many grams of NO2, its data we are supposed to calculate, how many grams of NO2 are required to produce 25.2 grams of HNO3? So basically, as per the question, in order to produce 25.2 grams of HNO3, in order to produce 0.4 moles of HNO3, how many grams of NO2 are required? So you have to relate NO2 with HNO. This is the one whose data is given as per the question. This is the one whose data is to be calculated. And the one whose data is to be calculated, that always has to be on the right side of the equation. So what I'll be writing? I'll be using these stoichiometry coefficients. I'll write, as per the stoichiometry, 2 moles of HNO3. 2 moles of HNO3 are produced from. 2 moles of HNO3 are produced from 3 moles of NO2, right? If 2 moles of HNO3 are produced from 3 moles of NO2, 1 mole of HNO3 is produced from 3 by 2 moles of NO2. But do we need to produce only 1 mole of HNO3? No. We need to produce 0.4 moles of HNO3. So 0.4 moles of HNO3 is produced from 3 divided by 2 multiplied by 0.4 moles of NO2. This is 1.2. That means 0.6. 0.6 moles of NO2. So what did we calculate? These are the moles of NO2. These are the moles of NO2, which are which are required to produce 0.4 moles of HNO. But was I supposed to calculate the moles of NO2 or mass of, right? Was I supposed to calculate the moles of NO2 or mass of NO2? Since we got the moles of NO2, but what was I supposed to calculate? Mass of NO2. Mass of is going to be moles of NO2 multiplied by the molar mass of. Moles of NO2 we got as 0.6 multiplied by molar mass of NO2. 32 plus 14 comes out to be 46, right? Solve it. Approximately the value will be 27. So this 27.6 grams, what is it exactly? What is it exactly? Right? What is it exactly? Quickly. 27.6 grams. It is basically that mass of NO2 which is required. Produce 25.2 grams of. Hope it's clear. Clear to everyone, people? Right? Okay. One more question. Give it a try. One more question and give it a try. Okay. What is the answer of this question, Afnan, if you remember? Afnan remembers the questions. What is the answer of this question? Quickly. Okay. How much HCl is needed? How much HCl is needed for complete reaction with 69.6 grams of MnO2? In the reaction, as per the question, in the reaction, how much HCl is needed? How much HCl is needed for the complete reaction with 69.6 grams of MnO2? Okay. How you are going to solve this question? Since I'm showing you the question solving with the help of mole method, so the reaction is already balanced. Now convert the given quantity into number of moles. So convert the mass of MnO2 into moles of MnO2. Number of moles of MnO2 is equal to given mass of MnO2 in grams divided by molar mass of MnO2. Right? So these are the moles of MnO2. These are the moles of MnO2, right? Okay. Now people understand. Understand properly what I'm going to do. As per the question, whose data is given to us? We are given with the data of MnO2. Whose data we are supposed to calculate? We are supposed to calculate the data for HCl. The one whose data is given, and the one whose data is to be calculated, we just have to relate these. Okay? And the one whose data is to be calculated, that has to be on the right side. I can say from the stoichiometer, 1 mole of MnO2 reacts with 4 moles of HCl. 1 mole of MnO2 reacts with 4 moles of HCl. That means 69.6 divided by 87 moles of MnO2 reacts with 4 multiplied by 69.6 divided by 87 moles of HCl. So what did I calculate? These are basically the moles. These are the moles of HCl which are enough to react with these many moles of MnO2. But was I supposed to calculate the moles of HCl? No. I was supposed to calculate the mass of HCl. So mass of HCl is going to be moles of HCl multiplied by molar mass of HCl. Right? Moles of HCl we got to know as 4 multiplied by 69.7 divided by 87 multiplied by molar mass of HCl is 36.5. Just solve it and this is going to be the answer of the question. So let me know what is the value you'll be getting after solving this equation. It is 116.8 grams, right? It is 116.8 grams of HCl. So this is basically the mass of HCl which is required. This is the mass of HCl which is required to react with 69.6 grams of MnO2. To react with these many moles of MnO2. I hope it's clear to everyone. Yeah? Is it clear, people? Is it clear to everyone? Is it clear to everyone? Let me know in the chats with the thumbs ups quickly. Okay. Perfect. Let's have a look on how stoichiometry, how this mole method is used in sequential reactions, right? So first of all, what are sequential reactions? Let's get to know. Sequential reactions are the ones which are carried out in a sequence. They are not one-step reactions. They are multi-step. For example, you have got a reaction like this. A plus B, it gives C. C upon reaction with D, it gives E. If I add these two reactions, on adding these two reactions, this C and this C got cancelled. So my net reaction is going to be A plus B plus D, it gives E. Now, if I ask you whether this particular reaction is completed in one step or more than one step, this reaction, it's completed in more than one. Right? So basically, the C which is getting formed in the first reaction, C is the product of the first reaction, right? And C, the same C, it is the reactant of the second reaction. So can I say the product which is formed in the first reaction, that is becoming the reactant of the second reaction? Yeah, right? So whatever amount of C gets formed in the first reaction, same amount of C gets consumed in the second reaction. Do you agree with that? Whatever C will be getting formed in the first reaction, same amount of C will be consumed in the second reaction. Yeah? This is something which you need to remember, that's all. Whatever C gets formed in the first reaction, same amount of C is being utilized, is being consumed in the second reaction. Okay? Now, how we are going to solve the questions then? Look at this question. As far as this particular sequential reaction is concerned, in the first reaction, KClO is getting formed. And whatever KClO is getting formed in the first reaction, same amount of KClO is being consumed in the second. Whatever KClO3 is getting formed in the second reaction, same amount of KClO3 is being utilized in the third. And eventually, what is getting formed? Eventually, KClO. What we need to calculate? Calculate the mass of KClO4. Calculate the mass of KClO4 formed on starting with 568 grams of Cl2. Right? So the question is, we are starting with 568 grams of Cl2. On starting with 568 grams of Cl2, calculate the mass of KClO4 which gets formed at. Which methods are we using? We are using the mole method. In the mole method, always the first step, convert the given quantity into number of moles. Given quantity here is mass of Cl2. Convert the mass of Cl2 into moles of, right? Given mass of Cl2 in grams, divide by molar mass of Cl2. It comes out to be. Okay. So whether you want to say that you are starting with 568 grams of Cl2, or you can say you are starting with 8 moles of Cl2. The choice is completely. Okay. Now guys understand. Cl2 and here KClO is getting formed. This KClO is the reactant in the second reaction. Here KClO3 is being formed. This KClO3 is the reactant in the third reaction. And over here KClO4 is being formed. Okay. Now understand. First of all, you need to balance all these steps, and right here in this question, the steps are already balanced. From the stoichiometry, can I say 1 mole of Cl2 is producing 1 mole of KClO? So 1 mole of Cl2 gives 1 mole of ClO. 1 mole of Cl2 gives 1 mole of KClO. Do I have only 1 mole of Cl2? No, we have 8 moles. If 1 mole of Cl2 gives 1 mole of KClO, I can say 8 moles of Cl2 will produce 8 moles of KClO. So this 8 moles of KClO, I can say from the first reaction, 8 moles of KClO is being produced. And whatever KClO is being produced in the first reaction, same amount of KClO will be utilized in the second reaction. How exactly? See, this is 3 here, this is 1 here. From the stoichiometry, can I say 3 moles of KClO gives 1 mole of KClO3. That means 1 mole of KClO3 gives 1 by 3 moles of KClO. Sorry, that means 1 mole of KClO, it gives 1 by 3 moles of KClO3. Hey guys, it's simple. 3 moles of KClO gives 1 mole of KClO3. So 1 mole of KClO, it gives 1 by 3 moles of KClO3, right? How much KClO was being formed in the first reaction? 8. Whatever KClO was formed in the first reaction, same amount of KClO is utilized in the second reaction. So if 1 mole of KClO gives 1 by 3 moles of KClO3, so 8 moles of KClO which got formed in the first reaction, right, now are going to give 1 by 3 multiplied by 8 by 3 moles of KClO3. So we got to know the moles of KClO3 which are being formed in the second reaction. That's 8 by 3. So 8 by 3 moles of KClO3 got formed in the second reaction. And whatever moles of KClO3 got formed in the second reaction, same moles of KClO3 will be utilized in the third reaction. Have a look. 4 moles gives us 3 moles. So 1 mole gives us 3 by 4 moles. So 8 by 3 moles will give us, let me write it one by one, 4 moles of KClO3. Upon reaction in the third step, it gives 3 moles of KClO4. So 1 mole of KClO3. 1 mole of KClO3. It gives 3 by 4 moles of KClO4. But do I have only 1 mole of KClO3? No, we do not have 1 mole of KClO3. We have got 8 by 3 moles of KClO3 here. So I can say 8 by 3 moles of KClO3 gives 3 by 4 multiplied by 8 by 3. The value comes out to be 2 moles of KClO3. So what did I calculate? I calculated the moles of KClO4 which are being formed at the end of the reaction. These are the moles of KClO4. These are the moles of KClO4 which are being formed at the end of the reaction. But as per the question, was I supposed to calculate moles of KClO4 or mass of KClO4? I was supposed to calculate the mass of KClO4. Since moles you have calculated, multiply the moles by its molar mass. That clear? Is that clear, people? Is that clear to everyone quickly? All right. Let's see one more question then. Okay. One more sequential reaction question. First of all, as per the question, you are starting with 134.4 liters of NH3. You are starting with these many liters of NH3. So convert the given quantity to number of moles. So first of all, let me calculate number of moles of NH3, which will be equal to given volume of NH3 in liters divided by 22.4. This value comes out to be 6. Yeah, approximately 6. Let me take the value approximately as 6, whatever it comes. Okay, leave it. So as per the question, we are starting with 6 moles of NH3. In the first reaction, as you can see, NO is being formed. And whatever NO is being formed is utilized in the second. In the second reaction, NO2 is being formed. And whatever NO2 is being formed, that's utilized in the third reaction. And in the third reaction, at the end, what's being formed? HNO3. And we have to calculate mass of HNO3, which gets formed at the end. How exactly we are going to see? As per the question, 4 moles gives 4 moles. So 1 mole gives 1 mole. So 6 moles of NH3 gives 6 moles of NO. So in the first reaction, 6 moles of NO are being formed. 6 moles of NO are being formed. Now, whatever 6 moles of NO are being formed, same moles of NO are being utilized in the second reaction. Okay, have a look. 2 moles gives 2 moles. So 1 mole should give 1 mole. That means it's 6 moles should give 6 moles of NO2. So as per the question, I got to know 6 moles of NO2 are being formed. 6 moles of NO2 are being formed in the second reaction. And whatever NO2 is being formed in the second reaction, same amount of NO2 will be utilized here. Right? Have a look. Can I say 3 moles of NO2 gives 2 moles of HNO3? If 3 moles gives 2 moles, so 1 mole gives 2 by 3 moles. 6 moles will give 2 by 3 multiplied by 6. The value comes out to be 4. So 4 moles of HNO3 is being formed at the end. But am I supposed to calculate moles of HNO3 formed or mass of HNO3? Mass of HNO3 will be moles multiplied by moles. It will be 4, 3, 12. 252 grams of HNO3 is being formed at the end. Is that clear to everyone now? Is that clear to everyone quickly? Is that clear to everyone quickly? Is that clear to everyone quickly? Okay. One more question of the similar type. As far as this question is concerned, calculate the mass of polyethylene that can be produced from 10 kg of calcium carbide. So you are starting with 10 kg of calcium carbide, and we have to calculate the mass of polyethylene being formed at the end of it. We are solving all the questions as per mole method. So what I'll be doing again, I'll be converting the given quantity into moles. Number of moles of CaC2 is equal to given mass of calcium carbide in grams divided by its molar mass. So these many moles of CaC2 we have with which we are starting, right? Now as you can see, CaC2 is forming C2H. And whatever C2H2 is being formed in the second reaction, it's forming C2H4 here. And that C2H4 is consumed here, and at the end polyethylene. We need to calculate the mass of polyethylene. All right, have a look. So from the stoichiometry of the reaction, look at the first reaction. Can I say 1 mole of CaC2 gives 1 mole of C2H2? 1 mole of CaC2, it produces 1 mole of C2H2. But do I have only 1 mole of CaC2? No, I've got 10,000 by 64. So 10,000 divided by 64 moles of CaC2 produces 10,000 divided by 64 moles of C2H2. So these are the moles of C2H2 which are produced in the first. Now whatever moles of C2H2 are produced in the first reaction, same moles of C2H2 are utilized in the second reaction. And as per the second reaction, 1 mole gives 1 mole, correct? So I can say 1 mole C2H2 in the second reaction, it gives 1 mole of C2H4, right? But do I have only 1 mole of C2H2? No. We have got these many moles of C2H2 which got formed in the first reaction. So can I say 10,000 divided by 64 moles of C2H2 should give me 10,000 divided by 64 moles of C2H4. What is this point? What is this point? These are the moles of C2H4 which got formed in the second reaction, and whatever moles of C2H4 got formed in the second reaction, same moles of C2H4 will be utilized in the third reaction. How exactly? Stoichiometric coefficient here is n. Here it's 1. So in the third step, can I say n moles of C2H4 reduces 1 mole of, this is something which you call as polyethylene, right? Reduces 1 mole of polyethylene. So from the unitary method, 1 mole of C2 reduces 1 by n moles of polyethylene. But do I have only 1 mole of C2H4? No. We have got these many moles of C2H4 which got formed in the second step. I would say 10,000 divided by 60 moles of C2H4 will produce 10,000 divided by 64 n moles of polyethylene. So these are the moles of polyethylene which got formed at the end of the reaction. But as per the question, Do I need to calculate the moles of polyethylene? No. I need to calculate the mass of polyethylene, which is equal to moles of polyethylene formed multiplied by molar mass of poly. What are the moles of polyethylene? It's 10,000 divided by 64 with N multiplied by molar mass of polyethylene. What is the molar mass of polyethylene? Carbon 12 to 24. 24 plus 4 is 28. So it's 28N, right? So multiplied with 28N. N got cancelled. So the value comes out to be 28 divided by grams. Solve it. That's going to give you the mass of polyethylene which got formed. Clear? So guys, can you solve these sort of questions as well? Yeah? Okay, so guys, this session will be ending here only. Since I told you there are some big chapters which will take 2 sessions, and whole concept is one of them, thermodynamics is one of them, right? So the rest of the chapters, the rest of the topics in this particular chapter, we'll be doing them on after 3 days, because tomorrow it's Grace sir session. Day after tomorrow it's Ambika ma'am's, then HSB sir's, then again it's my. Okay? Perfect. So this was your mole concept part 1, and mole concept part 2 will be done after 3 days. Perfect. I have told you in a week we'll be completing 4 chapters, right? 2 chapters from chemistry, 1 from physics, and 1 from bio. Since physics, it's vectors, that small chapter that will be done tomorrow only. In chemistry, your complete mole concept will be done. Like half is done today and half will be done on the 5th day. Okay? And HSP sir is going to take GOC. He'll be taking 2 sessions. Perfect. So 1 week, completely 4 chapters will be done. But everything, as you saw, I'm going to teach in detail in this batch. Perfect. Because I'm not going to skip a single thing you must have seen till now. Right? That's how the batch is going to continue. Okay? And do let me know, please and please, in the comment section of the video. Once the video ends, do let me know in the comment section, did you actually like the session? Do you want the sessions to be complete in a similar way? Or do you want to be, do you want me to be fast? Do you want me to be slow? Or did you like the pace? Did you like all these different problem patterns which I'm myself showing, right? Perfect. Yeah, PYQs are included here. We solved a lot of PYQs till now. Okay. Perfect, guys. So with this, I'll be taking leave. Let's come up with the part 2 of the mole concept after 3 days, right? Do let me know. Do write in the comment section that the challenge is accepted, right? Waiting for part 2 mole. Okay. So this is the Telegram channel on which you are going to get the PDF t.me/WASSIM SIRCHEM. This is the Telegram channel on which you will be getting the session PDF, and to write something in the comments that challenge accepted for mole part 2. And let me tell you, in the part 2 of mole, what all topics will be covering. Number 1, limiting reagent, percentage yield, percentage purity, mixture analysis, concentration. 5 topics are there. Okay. Hello. See you. See you in the second part of the mole concept then. Take care. Sleep well and do revise the same topics again. Otherwise, you might forget them. Okay. Otherwise, you might forget them. So do revise them again. Whatever topics are. Take care, guys. God bless you all. See you in the next session.